The questions we're about to cover make up around 35% of the SAT math section, so you're going to want to pay attention to these algebra basics, starting with linear functions. These guys are all about understanding linear graphs and y equals mx plus b, where m is your slope or a constant rate of change, and b is your y-intercept and some sort of a starting point. On this question, for example, it tells us that a line has a slope of 5/6. So we're looking for 5/6 in that m slot, meaning we can get rid of c and d. And it says g of 0 equals 2, which is actually a sneaky way of telling us the y-intercept, because at the y-intercept, the value of x is always 0. And this is in function mode where g of something, g of x, equals 2. That means when we plug in 0 for x, we get 2 for y. So our y-intercept is 2, not -2, so it would be choice B here. Of course, sometimes you're going to need to find the slope yourself, like in this question. One of the telltale signs that you need to find the slope yourself is if they don't give you the slope, obviously, and if they don't give you a y-intercept. Instead, what you're going to see are just 2 points. So here it's telling us g of 2 equals 10, which basically means we have a point of 2, 10. Again, remember, because with functions, whatever's plugged in here is our x, and then whatever's on the right side is our y, and it's giving us the point 519. And what we can do is we can use something called the slope formula, which is the difference in y divided by the difference in x. So this simplifies to 9/3 or just 3, which is going to be our answer. Linear equations in one variable bring constants into the mix, along with the concept of no solution and infinite solutions. Building on what we already know about y equals mx plus b, let's take a look at this question. So starting with constants, a constant is going to be any number that does not change compared to variables that do change. So variables are x and y, right? If I pull up a linear graph, depending on what part of the line we're on, you can see that x and y are changing all over the place, right? But a constant, something like the y-intercept, is one number. It's just going to be 2. Likewise, the x-intercept is just going to be 2.4 in this case. So anything that is constant simply does not change the way that x and y change. Now, as far as infinite solutions goes, infinite solutions means we have the exact same equation. So if I pull up Desmos again, and we have the same equation, I turn this on, that blue line is going to stack right on top of the red line, right? So basically everything about this equation is the same slope, same y-intercept. But what's really cool is if you have no solutions, you will also have the same slope. If I change this to +8, for example, you can see we get 2 parallel lines. So keep in mind, whether it's no solutions or infinite solutions, it means you have the same slope. With that in mind, we know that our slope is 4 on the left side, because remember that's m. So in order for bx to multiply into 4x, b would have to equal 4. So that's going to be our answer for this one. You'll also run into single variable equations like this one, where you're simply just solving for x. And with these types of questions, you can either set both sides of the equation equal to y using Desmos. So for this one, we obviously don't have x, we have m, but just keep in mind you're going to basically switch out any letter they give you for x. So setting both sides equal to y would look like this in Desmos, and then we just find our intersection, keeping in mind that we're looking for x, right? Because y technically isn't supposed to exist. So our answer would actually be -16. Or you can solve it like this. We can think of m plus 4 as any other variable. So if we have 6 of them and we subtract 8 of them, then there's only -2 of them. So we have -2 x plus 4 equals 24. Divide by -2 to get rid of that. And then we have x plus 4 equals -12. Subtract the 4 from both sides, x equals -16. Linear equations in two variables is where we're going to see standard form. That is ax plus by equals c. And in this form, as you're going to see in this question right here, it's actually easy to find the x or y intercepts. So for this one, it's asking for the x-coordinate of the x-intercept. And just like at the y-intercept, x equals 0, at the x-intercept, y equals 0. So we're going to plug in 0 for y, which makes this disappear. Then we just have 3 over 4x equals 1, multiplied by the reciprocal in order to divide by 3 over 4. So again, if you're dividing by a fraction, it's the same as multiplying by its reciprocal. That is the fraction flipped upside down. So then our answer is just going to be 4 over 3.
This is your obligatory Pomodoro break. This is your obligatory bum. This is your obligatory Pomodoro break. This is your obligatory break.
In word problems, it's also important to note that A and B are going to be some sort of a value, X and Y tend to be some sort of item, and C is going to end up being our total. So in this case, we see that we have a 30-minute cuddle session that costs $15. This $15 is a value, while the cuddle session would be our item. So I'm thinking we could have something like 15x, right? Because remember, 15 would stand in for A. And then it says these 10-minute cuddle sessions cost $5. So then we would have that plus our 5y. And this would be, like B. And our total is saying if the visitor spends $90 per month, so that would equal 90. Sorry, the llama's getting in my way there. And yeah, that looks like it's actually choice D. So that would be our answer. This is also the perfect launching point into systems of linear equations. Let's take this scenario and turn it into not one, but actually two linear equations. Let's start thinking about that standard form, right? Remember, we want to have A and B being values that are coefficients for some sort of an item, just like we saw in the last example. In this case, we have bomb bags, which is an item. And then we have another item, which is fairy bottles. And since bomb bags are 12 rupees each, we could think this is like 12x. And then fairy bottles are 8 rupees each, so plus 8y. And importantly, with systems of equations, if you actually have the value in front of x and y, which we do, you want to make sure you have value plus value equals value. And since this is in rupees, we want to have 300 as our total rather than 30, because 30 is 30 items, but the value is the rupees. So value plus value equals value. And then after that, we're going to do items plus items equals items. And typically with the items, we're just going to say X represents all of one item and Y represents all of the other item. So X is all of our bomb bags plus Y, all of our fairy bottles equals all of our items total, which is 30 items total. And from here, you can definitely use substitution or elimination, but I prefer to just plug it into Desmos at this point. It's a little bit faster, at least for me. So if we open up Desmos, I've plugged these in. We look for our intersection and it says 15, 15. Cool. So you might be thinking our answer is 15, right? Either way, we have 15 items, 15 bomb bags and 15 fairy bottles, but it's not asking us how many bomb bags. It's asking us how much he spent on bomb bags. So if he bought 15 bomb bags and each bomb bag is $12, then we have to multiply those together. And what is that? 180? So our answer will be 180. And then for non-word problems like this one, we can simply skip to the Desmos step, which is super convenient. So for this one, we can just plug these two into Desmos. And if we do, we get this 0.66667 as our X value. You can see that that's the same as 40 over 6. If you put in 6.667, you'll get the correct answer. But in case you got scared by that, you can go a more traditional route and use elimination, which would basically be multiplying the bottom by -1. Because if we do that, we can combine these equations, and this becomes -x minus 2y equals -10. Then when we combine them, our y's cancel out because 2y minus 2y is nothing. 7x minus x is 6x. 50 minus 10 is 40, and then we divide by 6 in order to get x alone. So x equals 40 over 6, which as you can see is going to indeed be that number that we're looking for. So either way, if you put in 40 over 6 as your answer or 6.667, you would get the correct answer for that one. The last concept is linear inequalities, and a lot of these questions will take the concepts that we already know and just transform them into inequalities rather than equations. That said, it's important to keep in mind that some of them are going to give us these turning words into math type questions. And the trick with these kinds of questions is just knowing how to translate words into math. So simply, a number m is going to be m. The word is, and this would include was, were, any form of to be, is equals, at most, well, it just changed it on me. So normally it would be equals, but because it says at most, this is actually an inequality, right? And at most means it's not going to be any higher. So it could be equal to, or it could be less than, but it can't be any higher. Then we have 5 less than, so that's going to be minus 5. I'm going to wait on that because I like to put that after. 4 times the value of n. So 4 times the value of n would be 4n. 5 less than would be minus 5. And this is true. Then it tells us if the value of n is -3, n is -3, what's the greatest possible value of m? All right, so now we need to plug in -3 for n. So I'm going to rewrite this. If we simplify this, m is going to be less than or equal to 4 times -3 is -12. -12 minus 5 is going to be -17. And if m can be less than -17 or equal to -17, the greatest possible value of m is going to be -17. It's not going to get any higher than that. You'll also want to know how to just find a solution to these guys. And with these types of questions, you've got a couple options. You could either plug in your answer choices to see whether or not they work. So like if I wanted to test A, I would say -5 is greater than 2 times -2 minus 2. And that would actually work. So pretty quickly we would have our correct answer. Alternatively, you could pull up Desmos and you can plug in your original inequality, and then you can kind of eyeball some of these points if you want. And then if you really want to test them, so like I can see -2, -5 is going to be down here somewhere, which would work. But then I could also go to a line just to be sure. I could put -2, -5, and it's going to pop up. I could label it so it's even more obvious, and you can see it's in the green there because anything that's beyond this dotted line in the green is going to be a solution. So just like that, choice A is going to be my answer. And in this case, the first method actually went a little bit faster for me. If you're scoring below 700 or running out of time in the math section, you're not taking full advantage of the Desmos calculator. In this video, I'll cover everything you should use Desmos for on the SAT, and I will also discuss some times when using Desmos is not the best choice. And let's actually start this with what I think Desmos is used best for, which is solving systems of equations quickly. Take this question, for example. Of course, if we're trying to find any sort of intersection and they give us two equations, especially if they're both set to y, it's pretty easy to just set them equal to each other. So we would have like x plus 3 equals 2x minus 6. Then we could subtract x from the left side and the right side. And then we could also add 6 to both sides. So then we get 9 equals x, which is pretty fast. But if you don't know what to do, or if it's straight up faster, Desmos is a great option here. If we open up Desmos, we just have to type in our equations here. So we had y equals x plus 3. Then the other one was y equals 2x minus 6. And as long as you've got your mouse, you can just kind of drag over to the intersection point. It's going to automatically make it very prominent and show you what the points are. And boom, we know our answer is 9 right there. So Desmos could definitely be a faster option. And if you don't know how to deal with systems of equations, it's the only option and a really easy option. By the way, make sure whenever you're practicing and you're using Desmos outside of Bluebook that you actually choose the correct version of Desmos. You go to desmos.com/practice and then you choose your assessment and then you just type in SAT. And now you know for a fact that you're using the actual College Board approved version that you will be using on test day. Let's look at another one here. This one is actually not even immediately obvious that it's a system of equations, but as you start reading, you can kind of figure it out because systems of equations are going to be usually two different categories of things. So for example, we've got R miles versus B miles, right? Biked miles versus ran miles. And each of those is going to have its own value attached to it. In this case, we've got 10 miles per hour if you're biking, 5 miles per hour if you're running. Another similar setup might be something like, you're buying a large ice cream or a small ice cream. You have two different price points. Anyway, that's all to say, when we see these different values assigned to the same type of thing, we know that we have a system of equations. And the first thing we need to do is actually write this out, regardless of whether we're going to use Desmos or not. So because we have R miles at 5 miles per hour, we could say like 5R basically. So each R is going to get 5 miles per hour. But because I'm planning on using Desmos, I'm actually going to just say that this is X. X is going to be my running miles, right? So I'll say 5X. And then we know that our biked miles are 10 miles per hour. So I'll make that my Y. And the reason I'm choosing X and Y is because Desmos is going to want a value of a constant if you choose a constant other than X or Y. So then plus 10Y. And then it says she ran and biked a total of 200 miles. So I know if I add all of those together, we're going to ultimately get 200. So that is an equation right there. And then we get another equation here. It says, and she biked for twice as many hours as she ran. So if her biking hours are Y, that would mean that Y is equal to 2X's, right? Twice the number of running miles. So now I have my system of equations. And from here, you could use substitution, you could use elimination. I would argue that whether or not you know how to use substitution or elimination, I think Desmos is going to be faster because you're probably going to want to end up using Desmos to do your multiplication or division or whatever anyway. So might as well just put the equations in and let it do all the work for you, right? So let me pull up Desmos here, and same thing, we're just going to put our equations in. We've got 5x plus 10y equals 200, and then we've got y equals 2x. All right, intersection point is showing up right here. Intersection point is 816, 816. So let's write that down real quick. X is 8, y is 16. All right, and then let's make sure that we know what we're answering here. It says, what is the total number of miles that Morgan biked? So remember, biked was y. So y is 16. But remember, that's not the total number of miles that Morgan biked. That's simply the value of y. The total number of miles that Morgan biked was 10y, remember? So what's 16 times 10? 160. And our answer is D. All right, one more example of systems of equations here because I want to show you systems of equations, it works even when it looks like it's not going to work. So on this one, you can kind of tell from the answer choices that it's pointing you towards the quadratic equation, right? And because of that, you might feel like, how am I supposed to use Desmos for this? But trust me, we can use Desmos for this. Let's do it. All we're going to do is what we normally do, plug these equations into Desmos. So let me pull it up. First one was x minus y equals 1. And then the other one was x plus y equals x squared. And I'm using my little caret, so I don't have to use the keypad down here. Get used to shortcuts. There's another tip for you. And if you want a separate video on those shortcuts, let me know. Maybe I can make one for you. Minus 3. So we've got our systems of equations, right? And the question was asking me, which ordered pair is a solution to the system of equations? Okay, so what's the issue here? Well, if we go and we drag down to our intersections, we've got a couple of them, but neither of them are in the form that we're looking for, right? We're looking for 1 plus the square root of 3 and the square root of 3 and stuff like that. So what are we supposed to do? Well, it's actually not that hard. We can just plug in our answer choices and see what they look like as decimals, and then we can match up from there. So the first one is the square root of 3 and 1 plus the square root of 3. Basically, we just need to know what the square root of 3 is, and then we could add 1 to it, because that's pretty easy to do in your head, right? So what is the value of the square root of 3? Let's see. Another shortcut, SQRT, boom. So square root of 3 is equal to 1.7. And the answer A said that our y value on one of these was the square root of 3. Obviously, it's not going to be negative, so let me look at this positive one. And what do you know? 1.732. So that is, in fact, a y value. And then the x value is supposed to be 1 plus the square root of 3. Well, if it's 1.732 and 2.732, that is 1 plus the square root of 3. So we got lucky. It was choice A, but if it wasn't choice A, we would eliminate. We would try out choice B, so on and so forth, and we would pretty quickly get our answer using Desmos. But yeah, our answer is A for this one. Desmos is also great for just choosing equations. Take this question for example. It says, line T has a slope of -1/3 and passes through this point. Which equation defines line T? So in this case, we're actually trying to choose which equation lines up with this line that's being described. Before we did anything with Desmos, I would probably go ahead and just eliminate choices A and B. You are going to have some knowledge about slope. Basically, y equals mx plus b is our slope-intercept form, and m is the slope. So choices C and D both have -1/3. Like it says -x/3, but basically that's the same thing as -1/3x, right? If you multiply -1 3 times x, you get -x/3. So those two have the right slope. So I already know it's between those two. And then it's just a matter of, is the y-intercept going to be 10 or is the y-intercept going to be 13? So for that, I can use Desmos. And the way I'm going to know what my right answer is, it's going to be the one that goes through 0.910, right? So let's try out answer choice C first. Choice C said y equals -x/3 plus 10. And we're supposed to be checking to see if 0.910 is on the graph, right? So we need to scroll over a little bit. We need to find 9. We could even zoom in so that 9 becomes a lot more visible. And then we're scrolling up and we look here. Do we have 910? No, we have 97. And the scrolling and the moving around is super easy only because I have a mouse. Oh yeah, and another bonus tip, use a frickin' mouse. If you're not using a frickin' mouse, what are you doing with your life? I'm wearing my glasses right now because I'm very serious about this. This little tool is going to make you so much faster. It's going to make everything so much easier. So I don't want to hear any excuses. Use a mouse. Anyway, so we know that that doesn't work. So from there, we could just eliminate C, and we know that D is the correct answer. But if you're feeling nervous, you could obviously go back to Desmos, change that y-intercept to 13 to match answer D. And then we go to 9, scroll up, and indeed that 0.910 does exist. So we're all good there. Something else that Desmos can do that a lot of students don't know is actually deal with those tricky constants questions. Now, to be clear, these constants questions come in a variety of forms. They could show up on a lot of different types of math problems. The ones that you can solve with Desmos are going to involve graphing or the XY plane in some way or another. So this one, for example, we say, how many times does the graph? So we know that we're dealing with graphs, right? Anyway, this is interesting because we actually have two different constants here. So how the heck is Desmos supposed to work? Well, let's take a look. Let's just open it up and we're going to put that equation in, y equals ax squared minus c. And you're going to notice when you do this that Desmos asks you if you want to add a slider. The answer to this question should always be yes. And I'll go ahead and add a slider to both. We'll take a look at this in a second. But first, what's the rest of the question here? So it says, how many times does the graph of the equation above intersect the graph of the equation y equals a plus c? Well, let's add that one. So we're going to add y equals a plus c. And let's go ahead and zoom in here because I can't see what's going on. If we just go based off of this, where it's automatically choosing 1 and 1, we have 2 intersections. And that is indeed the answer. So if we go back, it specifies that A and C are both positive constants. And really, no matter what happens, as long as these are positive, so if I change A to like, I don't know, 4.4, we still see 2 intersections, right? If I change C to 10, we still see 2 intersections, right? So you can see that no matter what happens, we're going to get 2 intersections. And to be clear, these sliders here, you just get to basically choose whatever value you want. Sliding around is fun and really helpful in certain circumstances that I'll show you in a second, but you could also just like put in a value, right? You could just say A equals, 999. It was 2 intersections, so our answer for this one is going to be C, 2. Here's another example of a question with a constant in it. This time it's saying the equation has no real solutions. So for this one, we do need the upfront knowledge that no solutions means no crossing over the x-axis, because a solution to a quadratic, we can tell that this is a quadratic here, we've got x squared, is going to be when the quadratic crosses through the x-axis. So basically, we want to plot this out, and then we want to choose the answer that shows the quadratic not crossing the x-axis at all. So I'll open up Desmos. This time we've got 2x squared minus 4x equals t. And then for whatever reason, it's not giving me the slider option here. It's just getting mad at me. But what I can do is I can say t equals, and then I can put in my answer choices. So the first one was -3. Boom. And if we look, I'm not seeing any crossing of the x-axis here. If I zoom back, but I'm not seeing it crossing over the x-axis, which makes me think, oh, this is probably our answer, right? Another option B was -1. So if I go to -1, we can see it crosses the x-axis twice. Another answer was 1. We can see it crosses the x-axis twice. The other answer was 3. So you can see it crosses the x-axis twice. So that answer, -3, where it doesn't cross over the x-axis at all, was our correct answer. So choice A. All right. And I wanted to show you just one more where I feel like the slider comes in really handy. So this one is labeled hard. We've got a constant. In this case, it's another quadratic, and it's asking us, the value of C when the equation has one solution. Well, as we already discussed, a solution is when it crosses the x-axis, right? So if you're familiar with quadratics, you should know that the only time you're going to get one solution is basically if the vertex is touching the x-axis. So that's what we're going to be looking for when we graph this out. So same thing, we're going to get Desmos out. We're going to put in our equation. This time we have -16x squared minus 8x plus c. And there it is, it wants us to add slider C. So this is where I think it really comes in handy, because as we move it around, you can see the graph is also moving around, which makes it really easy to spot when we get our vertex touching the x-axis, right? So I'm going to move it. Okay, looks like right there it's happening. And if we zoom in, sure enough, oh, boom, -0.250. So it's just touching the x-axis there, and that was a value of -1. So our answer, just like that, is going to be -1. Another great use for Desmos is just finding intercepts. So here's an example where we're looking for an intercept. Now, for these types of questions, if you know the trick, the rule, which is basically x-intercept means y equals 0, and y-intercept means x equals 0. Some of these are going to be easier and faster without Desmos, but that's assuming that you know the trick. What's really cool is if you don't know the trick, we could just plug this in real quick. So I'm going to plug in my equation, and a pro tip here, anytime you've got a function, you could definitely put in the function if you wanted. You could put f of x, f of x equals 7x minus 84. So it's going to recognize that as a line, but you could also just put y equals, because on the SAT, f of x is always going to be the same thing as y. So just for simplicity's sake, I'll have y equals. And then it was asking the x-intercept. So that's where it touches the x-axis. We go here, and that's 12, 0, right? So just like that, our answer is A, 12, 0. And that was pretty fast, but if you also know that the x-intercept is when y equals 0, we could pretty quickly say, 0 equals 7x minus 84. Move the 84 over. 84 equals 7x. And then divide by 7, divide by 7. 84 divided by 7 is 12. And I just realized I circled negative 12 instead of positive 12. It should be choice D here, not choice A. My bad. But yeah, that one's kind of a toss-up, depending on how fast you are at doing the arithmetic there. Here's another example where we're looking for an intercept. This time we're looking for the y-intercept. So let's start by saying we don't know what's going on here, right? Because we've got this crazy equation. It's looking scary. We have an x as an exponent. So, maybe we're freaking out. But no need to freak out, right? We've got Desmos. Let's pull up Desmos and throw that crazy equation in. By the way, as we continue through this video, if you want to start practicing and trying to use Desmos, you've pretty much got it down, right? What do? We put the equations into Desmos and kind of go from there. So feel free to pause the video and try these on your own first as we move through the rest of the video. But what was that equation we were looking at? It was f of x, so I'm just going to say y, equals, and then we had in parentheses negative 8. Then we had in parentheses 2, and then raised to the x power, terrifying, I know, plus 22. And then it was asking us about the y-intercept. Y-intercept is, oh, that's the x-intercept. I'm like, why are they giving me a weird, okay, y-intercept is 0, 14. So just like that, our answer is A. And this was rated hard, by the way, difficulty level 3. I don't think so, not with Desmos. But here's the cool thing. If you have the ninja skills and actually remember that the y-intercept is when x equals 0, and you know how exponents work, this is even faster without Desmos, I think, because basically this is 0. Anything to the 0th power is 1. So then we have negative 8 plus 22. 22 minus 8 is 14. Boom, answer's A. Even faster than Desmos if you got the skills required. Another great trick that Desmos can do is actually to help you boop the like button on this video. For real though, if you're enjoying the video, please give the like button a boop for me. But what I was going to say is Desmos is really good at finding the minimum or maximum of a parabola. So this is a great example, but for half a second here, let's just talk and clarify what a minimum and a maximum is. So if you've got a graph and you're looking at a parabola is either going to be a happy face or a sad face, right? We've got this sort of U shape that's either right side up or upside down. If we're looking for a minimum, that is the vertex, because right here, as you can see, it can never go lower than that. And you can see that the minimum is by definition the y value, because these guys are going to keep going in these directions for infinity, so they don't really have any limit. Same thing with a maximum. If we're looking at this guy, the vertex is going to be our maximum because it's never going to go higher than that point. Again, the y value is going to be the maximum. So whenever you see minimum or maximum and it's a quadratic, aka a parabola, just know that you're looking for the vertex and specifically the y value of the vertex. Now that said, this says for what value of x does it reach its minimum? So in this case, we're actually looking for the x coordinate of the vertex. Anyway, what are we going to do? You've guessed it. We're going to plug this into Desmos. So let's do that. And the equation was f of x. Again, I'm just going to make that y equals x minus 10 times x plus 13. Going to zoom out and zoom in. Actually, I've got a scroller on my mouse, so I can just scroll. And it looks like our vertex is here. And the x value is negative 1.5. Now, negative 1.5 is obviously negative 3 over 2. But another cool feature here, because you're going to notice that the answer choices are in fraction form. If you did negative 1.5, this little button right here, boom, negative 3 over 2. So if you ever need to convert to fractions, that's another cool thing that Desmos can do. A little bonus tip for you. So negative 3 over 2 is choice D. Our answer is choice D. And this was another hard question. I don't think it's actually that hard if you're using Desmos, which is fantastic. I wanted to show you one more of these because this one actually looks a little bit harder, and we've got another function, but in this case, they're throwing like a function within a function. They've got this f of x, but then they've got this g of x where it's like f of x plus 5, and then they're asking for the minimum again. So it's kind of wild. At least it looks kind of wild. And if you know how to do like, negative b over 2a to get your x coordinate of a vertex, which is, essentially what we're asking for, you could do that. But think about it for a second. What are we going to have to do? We're going to have to plug this in for every instance of x. Things are going to get crazy, right? So instead, what we're going to do is we're going to use Desmos. But let's talk about this function within a function for just half a second here. If it says f of x plus 5, all that means is in every case of x in our equation here, we're going to plug in x plus 5 instead. And I'll show you what that looks like in Desmos. So instead of 4x squared, we're going to have 4x plus 5 squared. And then instead of plus 64x, we're going to have plus 64x plus 5. And then the last part of it was plus 262. That doesn't change because there's no instance of x, right? So that's what our equation looks like. And we're looking again for the vertex. You can always hit the little home button here if you've been screwing around like I have. And then boom, there's a vertex. There's our minimum. Hover over it. Negative 13 is our answer. So that is choice A, negative 13. Here's another trick that Desmos can do that a lot of students don't realize. It can actually help you with inequalities. I would encourage you to definitely try this one on your own first. You can probably guess what we're going to do, but let's go ahead and get into it. So yeah, we're just going to plug these inequalities in. So let's open up Desmos. So the first one was y is less than or equal to x. And if you hit y and then you hit the actual less than sign and then you hit the equal sign together, they're merging together. So I actually just typed the less than caret and then equal and then they merge. So that's how you do that without pulling up the keyboard here. Definitely encourage you to get used to doing that because it's, at the end of the day, it's going to be faster and shaving off a few seconds is always a good thing. Anyway, y is less than or equal to x. And then our other one was y is less than or equal to negative x. Cool. And it was asking us for the solution to the inequalities. Now, normally a solution is where you have lines touching, but in the case of inequalities, a solution is just going to be where you have both colors merging. So you can see like everything that's shaded blue is that blue equation, everything that's shaded red is that red equation, and where they cross over down here, this is our entire set of solutions. So looking at our answer choices again, basically, we just want to look and say which one of these lives in that area. And you could eyeball it and probably be just fine. But if you want to get really fancy, you could also put in each point. And I'll do that just to demonstrate. So the first one was 1, 0. Oh, it wants the parentheses. I forgot. You got to give it 1, 0. You could even label it so it kind of pops up for you. We had negative 1, 0. We had 0, 1. And then we had 0, negative 1. All right. And you can see that the only one that actually exists in this area we're looking at is the 0, negative 1, the red one, which was choice D. So our answer in this case is going to be choice D. Another trick that Desmos can do that, again, a lot of students don't know is actually solving single variable equations. And this is especially helpful when you've got those, harder or trickier looking single variable equations. All right, so this is where things get really fun because for sure, I would say the majority of students I've worked with do not realize that you can use Desmos on these single variable equations. In this case, we've got one variable, t, right? So there's no, this could basically just be x. So we don't have a y value, we just have this t value. That said, I'm going to treat t as x. And when we are dealing with single variable equations, we actually can just set it up as two separate equations, and we're going to add y. So basically all you have to do is you take your left side and you say y equals my left side. So in this case, it would be y equals 5t plus 3, or so I'll change it to x, 5x plus 3, and minus 7x plus 3. And then my other equation would be y equals the right side. So y equals 38. And that's what I'm going to put into Desmos. Sorry about my sloppy writing, by the way. So Desmos, hello, my dear friend. That was y equals 5x plus 3 minus 7x plus 3, and then y equals 38. And you can see now it's giving us an option to change y if we wanted to, which is kind of fun. Anyway, we know y equals 38, so we'll jump up to 38, and we'll see that line there. And then our solution is negative 22, 38. What was it asking again? The value of t. Remember, t was x. So if x was negative 22, right? Negative 22, that means t is negative 22. So our answer is negative 22. So that question was, whatever. Not the easiest single variable question, but not super hard. Now, this single variable equation, on the other hand, I would argue looks a little bit scarier, right? We have x under a root. Like, this doesn't look like it's going to be fun to deal with. And then we have to choose a solution set. So, like, possibly more than one answer is going to work. Anyway, just remember what I said. We're going to say y equals the left side. In this case, square root of 2x plus 6. At least this time they're using x, so we don't have to change it. Plus 4. And then the other one would be y equals the right side, x plus 3. So that's what we're going to put into Desmos. So again, y equals, and remember SQRT for square root, 2x plus 6. If you hit the right arrow, boom, then you can just say plus 4 to get out of your little root there. And then the other one, down arrow, by the way. Keyboards, mice, super important. Y equals x plus 3. Cool. So those are my two equations. Let's go home real quick. Hello, friends. And then we're supposed to do the solution set, and it was just x, remember? So we don't care about y. So it looks like there's only one solution, and that solution is 5. So if we go to our answer choices, sure enough, 5, choice B is our answer. Desmos is also great for dealing with number of solutions questions. And I said this before, but try pausing this video right now, getting out that version of Desmos and trying this one on your own first. Because at this point, you have what it takes to solve these using Desmos. We're really just recycling what we've already been through, at least for this problem. But speaking of which, this one is obviously, like I just mentioned, how many solutions. We've already talked about how number of solutions is either going to be like when they touch, if it's a system of equations, or if we have some sort of a quadratic, like it seems we do here, then it's going to be how many times do we cross the x-axis. So let's put in this equation, x minus 1 squared equals negative 4. Ooh, actually, we could use the trick that we just talked about, right? Because we technically don't have a y, so we could treat this like a single variable equation where we say y equals x minus 1 squared, and we could say y equals negative 4. And in that case, the number of solutions is going to be the number of times that these two equations touch. So let's do it that way, just to kind of building off of what we were just doing. So open up Desmos, y equals x plus minus 1 squared, y equals negative 4. So number of solutions, 0. The line is down here, the parabola's up here. They're never going to touch, so number of solutions would be 0. Our answer is D, the power of Desmos. Another crazy thing, at least I think it's kind of crazy that Desmos can do, is it can actually help you to evaluate functions straight up. Let me show you. And I know what you're thinking here. That's too good to be true, but it's not too good to be true. Desmos can indeed evaluate functions. So this is the one case, if you're evaluating a function, basically it's giving us a function and then it's talking about some other stuff that happens if we plug in different values. This is the one case where I would recommend using f of x. So we're gonna put this in exactly as it appears, including f of x. So pull up Desmos here, f of x equals x plus 7, and then if you just highlight this and hit the slash sign, it'll divided by 4. So that's our function. And then it was asking us, what is the value of f of 9 minus f of 1? What do we have to do here? It's going to blow your mind. Watch this. F of 9 minus f of 1. 2. It's just going to give us the answer. That's what's up with Desmos. So the answer is 2, which means the answer is B. And yeah, Desmos can do that. You can also use Desmos for equivalent expression problems. So with equivalent expressions, this is definitely territory where some of you are going to be super comfortable and you can solve them quickly without Desmos. But again, if you don't know how to solve them, Desmos is just such a great option. And even if you do know how to solve them, I would say some of these are going to be faster with Desmos. This one in particular, I think, is faster without Desmos, but let me just show you basically what you want to do with equivalent expressions. You want to put in your original expression, obviously. So let's start by doing that. X squared minus 5. And then all we have to do to find an equivalent expression is plug in our answer choices. And the answer choice is going to create the same exact graph as the first one here, right? So I'll let you take a look here. If you want to try and plug these in and do it on your own first, but I'm going to plug these in now. So we had x plus the square root of 5 squared. So let's get that in. X plus the SQRT. Then that whole thing was squared. And you can see that that is not the same graph. And then the other one was x minus. So we could just replace this. That's also not the same. The other one, choice C, was x plus root 5 times x minus root 5. And here I can copy and paste. I know that I tried copying and pasting in Blue Book, and for whatever reason, even though this is the College Board official version, I don't know if it actually works in Blue Book, just as a little caveat there. But, oh wait, hold on. It wasn't supposed to be squared. It was supposed to be x plus the square root of 5 times x minus the square root of 5. And you can see this purple graph is the same as this green graph when we turn it back on. Yeah, so they're one and the same, which means choice C, the one that I just plugged in, is our answer. Now, this one, I would argue, is a lot faster if you know that this is a difference of squares, right? Because a difference of squares is we have x squared, and then it's going to be x plus the square root of this times x minus the square root of this. So in this case, it would be x plus the square root of 5 times x minus the square root of 5, which again is choice C. So that one should happen in about 2 seconds without Desmos if you know what you're doing. But if you don't know what you're doing, you might skip it and you might just never get the right answer. So good on you, Desmos. Now for a hard equivalent expressions problem like this one, it's really a toss-up. I know how to do this without Desmos, but it's hard to say which one would be faster. Let's just go through both real quick. So this is definitely a lot more complicated than the last one, so let's unpack it for a second. We know that ultimately we're going to have f of x divided by g of x. We also know that x is going to be greater than 3. That's not usually going to come into play in the Desmos world, but essentially we're going to have this, which is f of x, divided by this, which is g of x. So I would actually just do that in Desmos. So that's what I'm going to do. So we open up Desmos. We had x to the third minus 9x. Highlight that. Divided by x squared minus 2x minus 3. Okay. And then we're going to do the same thing that we did last time where we plug in our answer choices. So if you want to take a look at those and try it on your own first, there they are. But let's go ahead and do it. So the first one was 1 divided by x plus 1. And we can see that that's different. And with these, it's always going to be easy because there's some sort of consistency. Like for this one, all of the denominators are x plus 1, so we just have to change the numerator. Choice B was x plus 3 in the numerator. We can also see that's different. Choice C was x times x minus 3. X times x minus 3, also different. It's kind of a weird looking one. And then choice D, which we know by default is our correct answer, was x times x plus 3. And you see it disappears because it's the same. We can turn this off just to double check, and we can see that they're the same, right? Pretty quick. Like, honestly, I'm thinking Desmos. Oh, it's hard to say because we know our choice is choice D because of that. But let's go through what it would look like without Desmos, just for those of you who know how to solve this without it. Because here we basically have this difference of squares, except for instead of a difference of squares, we're adding an extra x to it, basically. So if this was just x squared minus 9, we would have x plus the square root of 9, aka x plus 3, times x minus the square root of 9, aka x minus 3. But then we know that we're actually doing x to the third, and it's going to be 9x. So basically, there's just an x on the outside of all this. And then our bottom one, this is just a quadratic that we can see if we factor, we want to multiply to -3 and we want to add to -2. So what would that be? Basically, it would be x minus 3 times x plus 1. -3 times 1 is -3. And then 1 minus 3 is -2. So that's how it factors. And then from there, we can eliminate x minus 3. Goodbye, goodbye. And then that ends up matching choice D. So yeah, it's hard to say which one of those is going to take longer. Obviously, as I'm explaining, that version takes longer. But when you're doing it quickly by yourself and you're not trying to explain to somebody in a YouTube video, it might be faster. So it's really up to you. Desmos is also fantastic for circle graphing questions, especially if you're not super comfortable with the circle equation. And this definitely falls into the same category of, tricks we've already learned at this point. I've shown you everything you need to do with Desmos, basically. So pause the video, try this one on your own first, but let's take a look. So in this case, we don't have a line or a parabola, we have a circle. And if you know the circle equation and you recognize this form, you might think, oh, well, I have to do completing the square on the left side, and then I convert it into the normal circle formula, which is going to be x minus h squared plus y minus k squared equals r squared. And then I know that the center of my circle is hk, because it is asking us for the center of the circle. And that's all well and good. But we could also just use Desmos. So let's plug this into Desmos. So let's put in our equation. We had x squared plus 20x plus y squared plus 16y. Oh, sorry, equals -20. It's like, what's going on? So there's our circle, and we'll zoom out a little bit here. And annoyingly, we don't actually get the center of the circle as a point, but what we can do is we can go to the very top, because that's going to show up, and we know we have -10, 4, and then the bottom we have -10, -20. So how do we take that to get the center of our circle? Well, we know it's -10. So for this one, we could actually just take a look and eliminate everything that doesn't have -10, and then answer choice B works. But let's say that we had two answers that had -10. Then what would we do? Well, we take our y values, 4 and -20, and we basically just need to find the midpoint, right? And how do we get the midpoint? We add them together and divide by 2. So -20 plus 4 is -16. -16 divided by 2 is -8. And indeed, -8 was the y coordinate, right? So that's how you would do it. Now this one, if you know circles really well, you can actually get your answer without Desmos in a matter of seconds. Because like I was saying, what you do with the left side here is you complete the square. And when you complete the square, basically you have to take half of this coefficient in front of x and then square it. So basically it becomes like x plus 10 squared And then same thing over here, it would become y plus 8 squared. And there's more to it because we have to add stuff to the right side. But if we're just looking for the center of the circle, we actually know that the left side is going to look like this. And then we just follow the formula. So then we have a -10 and -8. Because remember, it's minus h and minus k. So we get our answer in literally like 3 seconds if you know what you're looking at. And if that doesn't speak to you, I'm definitely skipping over a lot if you don't know what completing the square is. So just forget about it. The point of this video is Desmos makes things super easy. So be excited, be happy, be well. Now, one of the things that a lot of tutors like to show off is that Desmos can create tables, and that's certainly true, but most of the time I have found a student will actually complete a problem faster by not using Desmos. So while it is possible to create tables using Desmos, more often than not, those questions are asking about y-intercept or slope, which involves an additional process that just takes too much time, in my opinion. The same thing goes for things like mean and median. You can find those using Desmos, but those really basic questions are usually solved faster just by hand. Here's everything you need to know to solve systems of equations word problems on the SAT. First, the most common type of systems problem you're going to run into is going to be two linear equations in standard form. Standard form being ax plus by equals c, where x and y are some sort of items, a and b are values attached to those items, and c is our total. This first question is a classic example. We've got a concert venue sells ticket for 2 sections, right? So our items in this case are going to be tickets, and we have either general admission tickets or VIP tickets. So x plus y is going to be total general admission tickets plus total VIP tickets. And it tells us that 150 tickets were sold, right? So that would equal 150. We also get the value equation, right? General admission tickets are $40 each. Again, I was saying that general admission is X, so that would be 40X. And VIP tickets cost $100 each, so plus 100Y. And then finally, they give us a total value, 8,400. So the majority of these types of questions are going to be set up exactly like this, again, where we have items plus items equals total items, and value plus value equals total value. And of course, we can just plug this in to Desmos, pull that up real quick. And we're looking for our intersection here, 11040. Boom. So our answer is going to be 40. Here we've got another common subset. We've got a total. We know it's a total because it's saying the customer paid. So $9 is going to be equal to 3 pounds of apples and 3 pounds of bananas. So I can say something like 3A or 3B, but I'm going to stick with X and Y so that I can plug it into Desmos easily. So 3X plus 3Y. It also tells us that another customer paid $10.50 for 4 pounds of apples, so 4X, and 3 pounds of bananas plus 3Y. So here you can see it's a little bit different because we basically have 2 different versions of value plus value equals value. Once we have it set up, we can simply plug it into Desmos, which I will do. And it looks like regardless, they're both going to cost $1.50. So our answer is going to be choice B here, $1.50. So those items and values type questions are going to be your most common. But another common type is what I like to call these comparison equations. And it really comes down to just turning words into math. But let me show you what I mean when I say comparison. So in the first sentence, we are getting basically one of those value equations, right? It says he jogged at 6 miles per hour. So we could say that, jogging is X. So we could say 6X. And biked at 12 miles per hour. So we could say biking is Y. And he covered a total of 150 miles. So again, value plus value equals value, right? Nothing new here. But the second part that we get is a comparison. It says he spent twice as much time biking as he did jogging. And this is going to create an equation that involves just X and Y compared to each other. So if biking was Y, then Y would be equal to 2X because it would take 2 times the amount of jogging to get to his biking, which was, again, he spent twice as much time biking as he did jogging. And with these, sometimes students will get it mixed up. They'll put X equals 2Y instead. Just remember that the larger value should be by itself because we're going to have to multiply the smaller value in order to get to that larger value. And by the way, in case you're wondering what this cool system is, this is going to be the SAT Success Studio, which mimics the Blue Book interface. Really cool tool here. And this is actually one of 30 questions that you can buy for only $2 if you use the link in the description. So if you want to get additional practice, go ahead and use that link. Just $2 and you can practice all 30 of these questions. Anyway, let's move on. Let's finish this. I'm going to pull up Desmos, stick it over here, throw these in real quick. All right. And we've got 5 and 10. So it says, how many miles did Luis bike during the week? Now, remember, we said biking was Y, so we might be thinking, oh, it's 10, right? But we would be wrong because we have to remember that our original equation here was value plus value equals value. What was that value? That value was the number of miles, right? So X and Y don't represent the number of miles that Luis jogged or biked. X and Y represent the number of hours that Luis jogged or biked. So if Y equals 10, that means that he biked for 10 hours. But to get the number of miles, I'm going to have to take those 10 hours and multiply them by 12 miles per hour, right? So 12 times 10 would be 120. So in this case, my answer is actually 120. And that's one of the most common types of trickery that you're going to run into on the SAT with these questions. Make sure that you are giving the answer for value if they're asking about value rather than giving the answer for items. So at this point, you already have all the tools you need. I want you to pause the video and practice with this question. Just remember, we're looking for items, value, and comparisons. But let's go ahead and take a look. So this one says we've got a 36 long rope cut into 2 pieces. One piece is X feet long and the other piece is Y feet long. So this seems to be items plus items equals items, right? If we add X and Y together, and I'll just throw this directly into Desmos because why not? If we add X and Y together, that's going to be the full length of X plus the full length of Y to get our 36 feet. And then we have a comparison. The value of X is 6 more. And here I like to just turn words into math. The value of X would be X. The word is means equals. 6 more is going to be plus 6. Twice the value of Y. That would be 2Y, which would come before we add it. Boom. And that's it. What is the value of X? Value of X is 26. Just like that. All right, I got one more practice question here for you. Go ahead and give it a try. But here we go. I'm going to pull up Desmos. And this time it says we've got 2 types of tickets. So it seems like it's going to be those items plus items and values plus values. We've got floor tickets and we've got balcony tickets. So I'll say floor tickets are X. So we'll say 20X because they're $20 each plus 10Y. And then they do give us a total of 700 for the value. They also give us a total of 40 tickets. And remember, that would just be X plus Y because X and Y are the number of each ticket. Cool. Simple enough. Let's find our intersection, which is 30, 10. Now, we see 30 and 10 here, but remember, we want to check. Are we calculating the number of tickets or are we calculating the value, the dollars? And it says how much money in dollars was collected from floor tickets. So remember, floor tickets was X, so that's x being 30, but then we have to multiply 30 by 20. 30 times 20 is going to be 600. So our answer for this one should be choice D. Here's what you actually need to know to get 100% on linear word problems. First, the majority of these problems are going to come up in the form of y equals mx plus b, also known as slope-intercept form. And while you may know that m is our slope and b is our y-intercept, we need to think in terms of a real-world scenario. So instead, I want you to remember that y is our total, x is going to be the thing that affects our total. Often it's going to be time or a number of items. M, our slope, is going to be a constant rate of change, and b is going to be a starting point of some sort. With these things in mind, let's take a look at this first easy question. So in this scenario, let's go ahead and identify all those different parts, right? So it's telling us that the front of a roller coaster is at the bottom of a hill and is 15 feet above the ground. That is our starting point, right? That's where we're starting. So we're going to have y equals mx plus 15. Then it tells us the front of the roller coaster rises at a constant rate. So constant rate of change of 8 feet per second. That means our slope, m, is going to be 8. And just like that, we've got choice A as our answer. Obviously, they're using S instead of X here. And just to also identify Y and X, it says, which of the following gives the height? So the total that we're calculating, and as you can see, that stands in for Y, S seconds after it starts up the hill. Again, that's our S, right? So the number of seconds is going to affect the height because of that constant rate of change. Something else that will come in handy with these word problems is simply plugging it in. Whatever you know, plug it in. So this question right here, they're obviously starting by giving us an equation. And by the way, I would definitely encourage you to pause the video and try these questions on your own first to get some practice in. But let's take a look here. So it's telling us if Brittany's total take-home pay was this amount, and immediately total, that should be our Y, right? In this case, they're putting T in for Y. But basically, without reading the rest of the question, I already know that I just need to plug this number in for T and then solve for H. So let's do that real quick. And I'm just going to go ahead and pull up Desmos because why not? So we would have that 1576, and that would be equal to 1000 plus 18H. So we would need to subtract 1000 from both sides. So instead, that's just going to be 576. Then that would equal 18H. So then if I divide that by 18, I should get my answer, which is 32. So my answer is choice B here. Let's take a look at another one here. And again, pause the video, try it on your own first. But I'm looking for language that will signify either, a starting point or a constant rate of change. And I'm already seeing the scientists found that the height of the plant increased by an average of 1.2 centimeters per day. So that would be a constant rate of change. So I'm thinking y equals 1.2x plus b. Then it says if the height of the plant on the last day of the study was 36.8 centimeters, what was the height in centimeters of the corn plant at the beginning of the study? So if it talks about the height at the beginning, that would be our starting point. So we're actually solving for b. And remember, the concept here is just plugging stuff in. So it also tells us that this whole thing was going on for 12 days. So that would go in for our X. And then it tells us that on that last day, the total was 36.8. So that's going to go in for Y. And now we're just solving for B, right? So again, I'm just going to pull up Desmos. First, I'm going to multiply the 1.2 times 12, which I think is going to be like 14.4. Yeah, because 12 times 12 would be 144. And then I've got that 36.8 on the left side. So basically, I just need to subtract that. So 36.8 minus that 14.4, and I get 22.4. So my answer for this one is going to be 22.4. Some other questions are going to have you actually interpret things like the y-intercept or the x-intercept or even a point. But as long as we remember what those real world scenario values look like, it should be pretty easy. Let's take a look. And by the way, you might already notice that I'm jumping to the main question at the end. This is something I like to do because a lot of the time we don't need to read everything. So if I can just get away with reading this last question, I'm going to do so. It says, what is the best interpretation of the x-intercept? I can think of the x-intercept as y equals 0, right? Because whenever we're at the x-intercept, y equals 0, and vice versa. Whenever we're at the y-intercept, x equals 0. So what is x and what is y? So we have x hours, and y is going to be cargo that remains. I'm looking for no more cargo to move, basically. And if I look at my answer choices here, we have the team will have moved all the cargo. So that would be no more cargo to move in about 4.8 hours. I could calculate that, but let's eliminate first. The team has been moving about 4.8 tons of cargo per hour. No. The team has been moving about 25 tons of cargo per hour. No. The team started with 120 tons of cargo. No. And again, I'm just eliminating these because the x-intercept should be something about the team having no cargo, aka 0, because y should equal 0. So even without having to plug stuff in, I'm just going to go with choice A, which is my correct answer. Go ahead and try this one on your own first as well. But here it's saying, which of the following describes the meaning of the 2? So what is the 2? 2 is next to w. W is standing in for x, so 2 should be our slope, a constant rate of change. Let's eliminate just based off of that. A, the length with no weight attached, that is not a constant rate of change. The weight of an object will stretch the spring 30 centimeters. Nope. The increase in weight in newtons of the object for each 1 centimeter increase in the length of the spring. So here we have increase in weight for each centimeter increase in length. That is going to be a constant rate of change. D, the increase of length for each 1 Newton increase. So that's also a constant rate of change. Now I just need to figure out what I'm actually calculating. And technically, we can always think of the slope as a fraction of rise over run. That is to say, y over x. So what's our total that we're calculating? We're calculating length. So we should have length for each w. Again, that's standing for x. Length for each weight is what I'm looking for. Now, C says the increase in weight for each centimeter of length. So that's the opposite of what I want. But D says the increase in length, so that's our numerator, for each 1 Newton increase in the weight. So that's our denominator. So that is going to be our correct answer, choice D. Let's do one more of these interpreting questions. So here they're asking us to interpret P of 30. And just remember that in a function, whatever is in parentheses here is basically going to stand in for x, or in this case, they're using t instead of x. So we want to think x equals 30. And then whatever's on the right side of the equation is basically equal to y, or equal to the entire function. So I'm just going to say y equals 550. So what's the total that we're calculating? Because the total should be 550, right? It says the population of snow leopards can be modeled. So the population should be 550 because that's our total that we're calculating. And then what's affecting our total in this case? T years. So this should be 30 years after 1990, which I guess would also be the same as 2020. So we're looking for the year 2020. Cool. All right. With those two things in mind, let's eliminate. Population is predicted to be 30. No. Population is predicted to be 30. No. Population is predicted to be 550 in the year 2020. That seems good. And then if we were just making sure here, population predicted to be 550 in the year 2030. No, because it should be 30 years after 1990. Slightly more complicated is when you recognize the slope as a constant rate of change, but it's in the form of a fraction. And we did actually go over this just a minute ago in one of the other questions. So let's see if you can remember what I told you about the importance of rise over run. But let's take a look here. So the boiling point of water at sea level is 212 degrees. Sea level is like very clearly a starting point. So I'm already thinking we could probably get rid of A and B. We would just want to make sure that we're actually measuring degrees. And it says, which of the following equations can be used to find the boiling point of water in degrees? So yeah, that is going to be our starting point. So we can get rid of A and B just because of that. Now we're left with a couple of fractions. So remember, I said the slope is rise over run, right? So that means our total should be in the numerator, aka degrees. And in this case, it says 212 degrees. And then our denominator needs to be x, the thing affecting the total. In this case, it's feet, right? So then we just find the numbers that relate to that. It tells us for every 550 feet above sea level, so even though that's mentioned first, we know that's going to go in our denominator because that's x, right? So we want 550 in our denominator. The boiling point of water is lowered by about 1 degree Fahrenheit. So then we would have 1 degree Fahrenheit in our numerator. And it says lowered as well, which means we're subtracting that. So our slope should be negative 1 over 550x. Choice D here is the same thing, because if we multiply 1 over 550 times x, it would be x over 550, right? So sometimes you'll see it written that way, where you literally just have like x in the numerator. And yeah, choice D is our answer here. And then there's definitely going to be some more challenging ones that make you really think deep about what's going on. It might not seem like that y equals mx plus b, but it turns out it still is. So I don't want to give too much away, but basically this is just kind of a weird situation. But we can turn it into a regular looking y equals mx plus b. Go ahead and try it on your own first. Pause the video, but I'm going to explain what's going on here. So it's talking about renting a backhoe for up to 10 days. And a lot of the time you're going to see like for up to whatever. It kind of tells us that here. This is not really something we need to worry about. It's just giving us an arbitrary time frame in which this thing is occurring. So let's ignore the number 10, but it says 270 for the first day and then 135 for each additional day. So normally I would think we have y equals 135 for each additional day. That seems like a constant rate of change, right? So we'd have 135x plus our starting point, which is 270, right? And we'd be good. So we could just look at choice C, but we would be wrong because the language here says it's 270 for the first day. And it's telling us that X does indeed mean days. The problem is if we plug in 1 for X for our first day, we're not going to get 270. We're going to get 270 plus 135. We're being charged twice. So instead, we have to set it up like this. Y equals 135 times X minus 1 plus 270. So the x minus 1 is basically saying we're going to take the day that it is, but we're going to subtract 1 day because that first day shouldn't count. So this way, if we plug in 1 for x, our first day, it'll be 1 minus 1 equals 0. So then this gets eliminated, and then we pay that 270 that we were supposed to pay. So again, because that starting point applies to the first day rather than, like 0 as an upfront cost, we have x minus that first day so that we're not charging this normal rate for that first day. And of course, we can FOIL this out to 135x minus 135, and then 270 minus 135 is going to be 135. So then y equals 135x plus 135. That's going to be choice D. All right, we've got another weird one going on here. So take a look and see if you can figure out what's going on. But let's break it down. And this is a pretty long word problem. So I want to start with the main question just to get an idea of what we're supposed to focus on. Then we can kind of cherry pick from there. So it says, if X is the number of stations that will be set up for experiment A, and the remaining stations will be set up for experiment B, which of the following expressions represents the total number of teaspoons of salt required? So total, basically, we're going to have y equals one of these things because y should be our total, and then all of these are going to be equal to, I guess, the total number of stations, right? So let's figure out what's going on here. It says a science teacher is preparing 5 stations of a science laboratory. So we know that the total number of stations will be 5. Each station will have either experiment A materials or experiment B materials, but not both. Experiment A requires 6 teaspoons of salt. Experiment B requires 4 teaspoons of salt. So remember, X is going to be the number of stations only set up for experiment A. So basically, that would be 6x, right? Because we have 6 teaspoons of salt per station, 6 over 1. So 6x. And then the remaining stations will be set up for experiment B. So we would have our, X number of A stations plus 4 teaspoons of salt. And we know this is all equal to Y, so I could call this I don't know, I'll call it Z. 4Z. Z being the number of stations for experiment B. But here's the thing. If X is the number of stations for experiment A, the remaining stations will be experiment B. Since there's only 5 stations, Z would be those 5 stations minus the X number of stations that we've already used up for experiment A. So instead of 4Z, I'm going to say 5 minus X. Again, that's because they already told us that X is for experiment A, and we know there's 5 stations total. So experiment B would be those 5 stations minus however many stations we already used for experiment A. So that would be our setup. And then we could obviously FOIL this out, and then we get 6x plus 4 times 5 is 20 minus 4x. 6x minus 4x is 2x, so it'd be 2x plus 20, or choice C. All right, I got one more weird one for you here. So take a look and just kind of think about everything that we've learned so far and do your best to try this on your own first, but let's talk about it. All right, it is talking about a temperature increase of 9.10 kelvins. By how much did the temperature increase in degrees Fahrenheit? So it tells us that kelvins is X. So you might be thinking we could just plug in 9.1 for X and then we're good. However, we need to think about what's going on here. Our slope times our X is going to create this increase that we're talking about, right? So we do want to plug 9.1 in for X, but there's something else going on here. We also have 9 over 5, and it's being multiplied by X minus this other thing. So there's one of those weird starting point situations going on. Basically, if we're just trying to talk about an increase in X, we don't care about the starting point. So normally we would just get rid of 32, our starting point, but we have to keep in mind that that's not the entire y-intercept. We also would have to multiply 9 over 5 times negative 273.15, because that, if it gets FOILed out, will get added to our 32. So we could do that, but again, all we care about is the increase, that is the 9 over 5 times X. So we're literally going to ignore the rest of this stuff, and we're just going to do 9 over 5 times 9.1, and that's going to be our answer. So pull up Desmos real quick. We get 9 over 5 times, what was it, 9.1, and our answer is 16.38, just like that. So like I said, y equals mx plus b is going to be the majority of the questions you run into, but you're also going to run into standard form based questions. And for these, we're going to have to think about all of our components differently. So standard form is going to be ax plus by equals c. Now in this case, y is not our total. In fact, c is going to be our total. Instead, a and b are going to be values attached to x and y, which are some sort of items, and then finally C is our total. So let's actually look at some of these practice problems. So remember, we want to think AX plus BY equals C. And here it says a neighborhood consists of a 2-hectare park and a 35-hectare park. a 2-hectare park and a 35-hectare residential area. Now, remember, I said that A and B are values. These are values, right? Values in hectares. So I'm thinking already we're going to have 2x plus 35y equals C. The total number of trees in the neighborhood is 3934. So we would have 3934. And really, I'm just demoing this for you because they actually do give us that equation, right? 2x plus 35y equals 3934. But you can see where that's coming from now, right? Anyway, which of the following is the best interpretation of x? Well, let's take a look. So remember, x should be some sort of an item. In this case, the items are places, either parks or residential areas. Now, since 2 was attached to parks, x would be the park. So let's get rid of anything that doesn't involve park. We've got B, not mentioning parks, D, not mentioning parks. And then it says the average number of trees per hectare in the park versus the total number of trees in the park. So total should be reserved for choice C. And we do want the average number of trees per hectare because we do want that 2 to actually, interact with x. So choice A here is going to be our answer. Next up, we've got a certain apprentice has enrolled in 85 hours of training courses. The equation 10x plus 15y represents the situation. So I'm already recognizing that hours is going to be our total here. And we should have 10 hours and 15 hours attached to whatever our items are. Here it says X is the number of on-site training courses. So our items are going to be courses. And Y is the number of online. So we have either on-site X or online Y. How many more hours does each online training course take than each on-site training course? Well, based on what's going on with our situation here, it looks like each on-site training course, X, takes 10 hours, and each online training course, Y, takes 15 hours. So how many more? 5 more, right? 15 minus 10 is 5. Boom. Easy. For this last question, I'm actually going to use the interface that I was talking about earlier. If you do download those practice questions, this is the interface you'll be using to take them. So here we are, and as you can see, just like on Blue Book, you're going to have your reference sheet available with all of your geometry information. You're also going to have the Desmos calculator right here, which is really cool. There's also a little AI companion that you can use. One of the things that I like to do is if you're having trouble with a question, you say, I want to practice another question like this one, and it will actually write one. So anything that you know you're having a hard time with, you can get additional practice, which is really cool. Anyway, let's take a look at the actual question here. And I do encourage you, as always, to pause and try it on your own first. But let's see how this relates to our AX plus BY equals C. It says how many liters, and because we don't know how many, I'm going to just call that X. X of a 25% solution, of means multiply, 0.25 would be the same as 25%. So I'm going to say 0.25x, we're multiplying, must be added plus to 3 liters of a 10% solution. And I want to keep things in the same order. So I'm going to do my 0.1. And normally this would be our y, right? AX plus BY equals C. But it's telling us that y is 3 liters. So I'm just going to put 3 in parentheses here. To obtain, that would be equals a 15% 0.15 saline solution. Now, let's look at our equation and make sure that we're equal here, right? We have percentage attached to liters, percentage attached to liters, and then on the right side, we just have a percentage, but we need the liters as well. So we should have the same amount of liters on the left side and the right side. And on the left side, we know we have 3 liters here, right? So that would be 3, plus we have X liters here, plus X. So this would actually be our setup. And now it's as simple as solving for X. So let's do that real quick. This is going to turn into 0.3 this is going to turn into 0.45 plus 0.15x, and then I'll just keep this 0.25x. I'll go ahead and move my x's over to the left side, so I'll subtract 0.15x from both sides. That's going to be 0.1x. And then I'll move my 0.3 over to the right side by subtracting 0.3. So 0.1x equals 0.15. And basically, we're going to divide by 0.1, aka multiply by 10. So x is going to be 1.5. And that is going to be my answer. In this video, I'm going to give you 6 strategies that will help you solve any constants question you come across on the SAT. And strategy 1 is simply to use Desmos. On questions like this one, for example, it is asking us about a possible value of a in which the equation has 2 integer solutions. That should be pretty easy to visualize, right? So we pull up Desmos and we put in our equation, and then just make sure to hit add slider. If this doesn't show up, you can also just type a equals and then choose a value. And we're trying to find a possible value for a. And it tells us that a is greater than 0. So let's just start with any number greater than 0. We'll say 1. And remember, we want 2 solutions. And a solution for a quadratic is anytime the parabola touches the x-axis. So right now, this is not working, right? So what we can do here is we can take our slider and start moving it around. And you might be thinking, well, I guess there's a ton of options for a. But remember, it says 2 integer solutions. So we want to make sure that we have 2 integer solutions here. So if I go to like 8, oh, we actually have 2 integer solutions. I got lucky. But if we went to like 9, we could see these are not integers. So 9 would not work. What about 10? 10 would not work. But yeah, basically we just wanted to hit 2 integer solutions. It looks like 7 would also work. So either of those answers is going to be a correct option. So I'm just going to go with 7 since that's what we're hanging out on. My answer is 7. Here's another example. In this case, it says the parabola intersects this line at only 1 point. So this again should be something that we can visualize. So I'm going to pull up Desmos and I'm going to put in both of my equations here. So 2y equals 4.5. And then the other one was negative 4x squared plus bx. And again, we got to add that slider b. So if it intersects the parabola at only 1 point, since we have a horizontal line, we are literally looking for the vertex to touch the line. And you can see we're already getting close there if we didn't already get it. Did we get it? Boom, we got it. An easy way to check would be, is y, or is if 2y equals 4.5, then y should equal 2.25, which would be half of y, right? And that is indeed the case. So it looks like the value of b would be 6. So our answer here is going to be 6. And again, with both of these, the key is you just want to play with your slider until you get what you're looking for, right? Visually. It's even easier when you have answer choices because you can just plug in those answer choices. You don't even have to use the slider. Strategy 2 is going to be to plug stuff in. Now, through trial and error, as you're working through practice problems, you're going to realize that certain questions are not Desmosable, if you will. And this would be one of them. One strategy that you can utilize is simply to plug stuff in. So in this case, we're given a table with some values, including our constants, and we are given the slope. And since we know the slope is 2, we can actually set it equal to 2. And just to remind you, the slope equation is going to be the difference in 2 y values divided by the difference in 2 corresponding x values. I'm going to use these points here. That way I only have one unknown that I'm solving for. So I'll say 11 minus 7, that's my difference in y, divided by, make sure it corresponds, k minus 3. And then that is equal to 2 because that's our slope, right? That's the slope formula. So if we work this out real quick, we could multiply by k minus 3 to get 2k minus 3. And that's going to equal 11 minus 7, which would also just be 4. I'll go ahead and divide by 2 so that 2 equals k minus 3. Add that 3 to both sides, and now 5 equals k. So I know what k is. And then we could do the same thing for n, right? And we could either use these two, or we could just use these two. Let's just use these two again. So then our difference in y is going to be 7 minus n. Difference in x is going to be 3 minus 12. That's going to be equal to 2 once again. Multiply by 3 minus 12 to get rid of the fraction. What is 3 minus 12? Negative 9. 2 times negative 9 is going to be negative 18. That's going to be equal to 7 minus n. Subtract that 7 from both sides. 18 minus 7 is going to be negative 25. If negative n is negative 25, then n is 25, right? And then finally, k plus n would be 5 plus 25, which is 30. So our answer is 30. Go ahead and pause the video, try this one on your own first. Again, remember, we just want to plug stuff in. So for this one, it actually ends up being a sneaky little system of equations.
Sneaky, sneaky, sir.
It's because normally if we run across this kind of situation where both of our coefficients are constants, but they give us 2 points, we can plug both points in. Now we've got a system of equation. That said, I'm noticing a 0. And anytime you see a 0 in a point, you should get excited because it's going to eliminate one of the constants for us, meaning we can solve for the other constant just by plugging that 1 point in. So if we plug that 1 point in, 0, negative 3, all of a sudden, 0 times a is going to be nothing. Then we plug in our negative 3 for y. So we have negative 3k equals 6. And now we're solving for k, right? Divide by negative 3, and k should equal negative 2. Now, what's it asking us? What is the value of k? So we actually already solved this one, just like that. All right, so pause the video, try this one as well. It's another plug it in type question. And this one's definitely a little bit scarier looking. At first, it looks like we have a quadratic, but no, this is not ax squared. This is a to the x. So some weird stuff going on here. But let's try to plug in what we can and figure something out. The first bit of information that they give us is the function itself. And then they tell us the y-intercept of a different function, f of x, this one, minus 12. Simple enough. We just need to basically think of this and then have the negative 12 in there, right? And remember I said get excited when you see 0. If it gives us a y-intercept, it's giving us a point where x equals 0. So let's actually plug that in. Y is the function itself. So we would have negative 75 over 7 equal to negative a to the x. We know that x is 0, so negative a to the 0 plus b. Importantly, we need to know that anything to the 0th power is 1. So even though it's not going to make this completely disappear, it is going to give us an actual number. Negative 1. Oh, and I almost forgot my my minus 12 here. So anyway, we've got negative 1. We also have negative 12. So that becomes a total of negative 13. So b minus 13 is going to be equal to negative 75 over 7. And from here, we just need to add 13 to the left side to find out what b is. And let's actually just use Desmos for this. Because if we put in negative 75 over 7 plus 13, it's going to give us this hideous decimal, but we also have this guy right here. Just click this button, turns it into a fraction. So now we know b equals 16 over 7. All right, so let's write that down. b equals 16 over 7. And then let's just put in the other piece of information we have in order to get a, because that's what we're supposed to figure out, the value of a. So it says the product, that means multiply the product of a and b. So a times 16 over 7 equals 320 over 7. To get rid of that 16 over 7, we just divide, 320 over 7 divided by 16 over 7. It's the same as multiplying by the reciprocal, or again, we can just take advantage of Desmos, which I would prefer to do. So let's literally just put this in. Again, we're doing 320 over 7, and then we have to divide all of that by 16 over 7 to get a by itself. And then it gives us a nice round number, a equals 20. So our answer here is going to be 20. Strategy 3 is to apply rules for infinite and no solutions. And for these questions, you just have to know one simple rule. If you're dealing with either infinite solutions like we are here, or no solutions, regardless, your equations are going to have the same slope and they're going to have the same ratio between their coefficients. Usually we can get away with just focusing on the slope. So for this one, if we have 2x, in order to get to 2x, a would need to equal 2, and that's it. Pause the video and try this one on your own first, but it's the same concept. If we are dealing with, in this case, no solutions, we're going to have the same slope. So again, the only part of this that we're concerned about is the part that's attached to x, because that is our slope, right? So let's just isolate this, and we'll isolate this. 3kx equals 48 over 17 x. We can divide by x to get rid of these guys. And even though this is scary looking, we're just going to use Desmos, because basically we'd need to divide by 3 to get k by itself. So 48 over 17 divided by 3 is 16 over 17. So our answer, k equals 16 over 17. Strategy 4 is just to find x or y. Occasionally, you're just going to be asked to solve for a point, and these are almost not even constant questions, because at the end of the day, you're just solving for x, right? In this case, or maybe in another case, you'd be solving for y. We could actually use Desmos for this as well. So let's pull up Desmos and throw this in, and I'm just going to use y instead of h of x here. So I've got my parabola here. And if we used Desmos, we could graph it, and we know that our first point was 0, 0. So our second point is going to be t0, aka 8, 0. And that's one way that we could do it. But this one, there's actually a really cool shortcut. Because one of our x-intercepts is at 0, 0, and the vertex is always halfway between our two x-intercepts, this is in vertex form. So we know that our vertex is 4, negative 32. Basically, if we started at 0 and we went to 4, we would go another 4 to get to the other intercept, and then we would know that it's 8 that way. That would require a little bit more knowledge of vertex form and everything, but definitely going to save you a few seconds if you didn't want to go the Desmos route. Strategy 5 is a really cool one. You actually get to choose your own numbers. And for these, I really do mean choosing your own numbers. So in this question, for example, they tell us that a and c are positive constants. So I can literally choose any positive constant that I want for a and c. So let's do that. And let's combine this with Desmos as well. So if I pull up Desmos, we're going to put in our equation, and we're going to add sliders for all. Whoops, capital X. There we go. Add sliders for all. And again, they should just be positive constants. It automatically sets them to 1, so we're good. And how many times does it intersect the equation y equals a plus c? Well, let's write that one as well. Y equals a plus c. Looks like it intersects it twice. So our answer is 2. Choice C. Strategy 6 is to match up your two expressions. Now, we were sort of already employing this strategy a bit when we were doing the no solutions and infinite solutions, because we were just focusing on the coefficients of x, since we know that no solutions and infinite solutions have the same slope. For these types of equivalent expression problems, we're going to more or less do the same thing. We're just going to make sure that we match up and focus on whatever it is they want us to. In this case, b. So if we look at this expression, we see that b is attached to x. So I'm only going to worry about stuff that's attached to x up here, because all of the coefficients of x are going to have to be equal to each other on both sides of the equation. So while I could FOIL out this whole thing, instead, I'm just going to be lazy about it, and I'm going to say 3x times 6 plus 19x times 23, or negative 23. Again, it's just because that's what b is attached to. And in fact, we could also just ignore the x's at this point, because we're going to divide by x at some point, right? So my answer is just going to be 3 times 6 plus 19 times negative 23. Pull up good old Desmos for that. 3 times 6 plus 19 times negative 23. And our answer is negative 419. And that's it. This one definitely looking a little bit more complicated, but I would encourage you to pause the video and try it on your own first. Again, remember, we just want to focus on matching up parts of the equation that must be equal to each other. So in this case, it's asking about A, B. And you might be thinking, well, let's find out what A is, and then we'll find out what B is, and we'll multiply them together. Or we could just find out where AB exists and see if that works. So if I look at the left side of the equation, the only time that we're going to get AB is when we multiply AX times negative BX, which would be negative ABX squared. That means on the right side of the equation, all I care about is this negative 9x squared. So you might be thinking, okay, negative ABX squared equals negative 9x squared, but we're not quite done because we need to make sure that we have all the x squareds from the left side of the equation as well. And the only time that we're going to get that is when we multiply 5x squared times 3. So it'll be 15x squared. Now, from here, let's do a couple of things. First, let's get rid of the x squareds. We'll divide the whole equation by x squared so that we don't have to worry about that anymore. And now we just have to subtract 15 from the right side. Negative AB equals, what's negative 9 minus 15? Negative 24, which means AB equals 24. Boom. That's the power of the matching trick. All right, last matching question here. Go ahead and try this on your own first, but here we go. So this one is looking a little bit different, but it's actually the same concept. We want to get the left side to look like the right side so that we can just match up the parts of the equation that look like each other, right? So big difference here is we have one fraction versus these two fractions. This actually just goes back to the basics of adding fractions together. In order to add fractions, you need a common denominator. Right now, these guys do not have common denominators. But in order to give them common denominators, we just multiply one of them by the denominator of the other. So basically, 2 over x minus 2 would get multiplied by x plus 5 on the top and the bottom. And the reason we're allowed to do this is that anything divided by itself is 1. So if we multiply this fraction by 1, we're really not changing anything because anything times 1 is itself, right? So this obviously can combine into this big fraction, and then we FOIL this out. 2x plus 5, 2 times x is 2x, 2 times 5 is 10. So that is part of our new numerator. And then this is going to go through the same operation, except for we're going to multiply by the denominator of the other fraction. Again, this is creating that common denominator. And in case you didn't notice already, yeah, it's going to be the same denominator as we see on the right side, which is going to come in handy. So 3 over x plus 5 would get multiplied by x minus 2 and x minus 2. So 3x minus 6. And all of this stuff is in the numerator of our new combined fraction. And we know that our denominator is going to be x plus 5 times x minus 2, which again is the same as this fraction on the right side. So at this point, we could actually ignore it. We're going to say, ignore the bottom. Basically, we're multiplying everything by the bottom so that we're just going to be focusing on the top portion now. So all we have left to do is to simplify this, combine our like terms. 3x plus 2x is 5x. 10 minus 6 is 4. And now you can see that we're matching because if 5x plus 4 equals rx plus t, then r is 5 and t is 4. And then it says, what's the value of rt? That would be 5 times 4, also known as 20. Okay, here's what you actually need to know about triangles for the SAT. The first thing that you're going to be tested on is the simple fact that triangles have 180 degrees. So if a triangle only has 180 degrees, then you could subtract your 25, subtract your 35, and what is that? 180 minus 60. So then 120 would be your missing angle. This is on the cheat sheet, so you don't need to memorize it. But if you don't have it memorized, what are you doing? And this is also a very basic example of what these might look like. I'll be including a link to a practice video at the end of this video if you actually want to work on the harder questions that will show up on the SAT testing these concepts. Next up, we've got types of triangles. And while this is not on your cheat sheet, there are several subtypes of the right triangle that you will find on your cheat sheet. More on that later. So right triangles are pretty straightforward. You just need to know that you have a right angle, and these are going to lend themselves to the Pythagorean theorem and special right triangles, which we'll cover in a minute. For equilateral triangles, you need to remember that all the sides are equal. So that means you have equal angles as well. And since you can only have 180 degrees in a triangle, by definition, they would all have to be 60, right? Because 60 times 3 is going to be 180. So that's really important to know about equilateral triangles. There's also one other thing that's important about them that I'll show you when I get to the special right triangle section. And then isosceles triangles, you just have to remember that they have two equal sides and two corresponding equal angles. So if you ever see that you have two angles that are the same, you know by default that the two sides are the same and vice versa. There are other types of triangles that exist, but I've never seen them asked about on the SAT. So these are the ones you need to worry about. While not quite as common, you are sometimes also tested on the triangle inequality theorem. And this looks a little bit more complicated than it is. Basically, it's saying the sum of any two sides is greater than the third side. So A and B is going to be greater combined than C would be by itself. A and C together would be greater than B, so on and so forth. That's it. An example question might be in triangle ABC, side A is 13 feet long and side B is 5 feet long. What is a possible side length for side C? So see if you can figure this out on your own. And at a glance, you might be thinking, well, according to the rule, the third side needs to be longer than the two other sides combined. So I feel like we have two right answers here, right? Because like 19 is going to be too big because 13 plus 5 is 18. And then 18 is going to be equal, but they're not allowed to be equal. It has to be greater. So then like 8 and 12 would both work, right? The problem is 8 plus 5 is 13, which would be equal to that third side when we combine B and C together. So 8 feet would not work either. It's going to be 12 feet. It would also behoove you to know the exterior angle theorem. This is going to be helpful for questions like this one on the SAT. And basically, the exterior angle theorem is if you have a couple of angles, let's say we have A, B, and C, the rule is the exterior angle of any one of these three angles is going to equal the other two added up. So let me actually show you what that looks like instead of just saying it. So let's say we have this angle here. We'll call this angle D. D is going to be equal to A plus B. And if you think about it, it makes sense because a straight line is also 180 degrees. So if you take 180 degrees and subtract C, you're going to be left with A and B because there's only 180 degrees in a triangle. Next, we've got the Pythagorean theorem and Pythagorean triples. And your cheat sheet is going to give you the Pythagorean theorem, which is one you probably already have memorized. It is A squared plus B squared equals C squared. And the only thing that students tend to forget about this, at least the ones that I work with, is that C is the hypotenuse. So basically, you're good to switch A and B around. Those are arbitrary, but C must be the hypotenuse. So if we knew, for example, that this was 3 and this was 5, and we were trying to figure this out, we would not do 3 squared plus 5 squared equals x squared. We would do 3 squared plus x squared equals 5 squared. And if you know your Pythagorean triples, you would know that this is a 3, 4, 5 triangle, and you wouldn't even have to do this because indeed 3 squared plus 4 squared would equal 5 squared. So let's quickly talk about those other Pythagorean triples. The most common ones that you're going to run into on the SAT are the 3, 4, 5. That is the most common. And then I would say tied for likeliness of showing up would be our 5, 12, 13, and our 20, 21, 29. These two are usually just going to be these actual numbers. The 3, 4, 5, though, you might see, sometimes you'll see a 6, 8, 10, or even a 9, 12, 15, or possibly a 12, 16, 20. So just keep in mind, this 3, 4, 5 ratio can get scaled up. It is the most common Pythagorean triple you're going to come across on the SAT. A Pythagorean triple just being a common set of whole numbers that you will see on a triangle based on the Pythagorean theorem. And of course, this should go without saying, but this only applies to right triangles because we need that hypotenuse, right? So this works for right triangles only. All right, the last of our more basic stuff is going to be the area of a triangle. And this is on the cheat sheet. It's just BH over 2, base times height divided by 2. The one thing that you want to remember about this is the definition of base and height. Because if we have a right triangle, it's going to be really straightforward. We have a built-in base, which by definition should just be a flat surface that we're sort of, setting the triangle down on. And then our height should go straight up and down. And with a right triangle, we get both of those things in our legs, right? So it's just leg times leg divided by 2. That said, it's not quite as easy if we have a more temperamental triangle, say something like this. We have a beautiful base, right? We could set our triangle down like that. And we're like, oh yeah, that's nice. But then these other sides are not going straight up and down. They're all angular. So our height is actually going to be this line here that doesn't exist on the triangle. So we're going to have to create that and kind of figure things out from there. So that's the one thing you want to keep in mind with area. All right, getting into the more advanced stuff, and this is not going to be on the cheat sheet. We have similar triangles, which show up all over the place. So similar triangles, in a nutshell, just have the same angles. So to make things simple, let's take a couple of right triangles, and we could say, going back to what we learned about Pythagorean triples, let's just say this is a 3, 4, 5 triangle, right? And the degrees for these guys are roughly 37 degrees and 53 degrees. And then obviously that's 90 degrees, right? So if we have a similar triangle, this guy, here, let's give him a different color. We have a similar triangle, this guy right here, he is also going to have the same exact degrees. So we got 53 up here again, we've got 37 down here again, but visually, we can see this guy's bigger. So what's the relationship between the sides? Well, the cool thing is, anytime you have similar triangles, because they have the same degrees, they're going to be proportional. So if this side were 6, I would know that this whole thing, as far as the perimeter goes, is twice as big. So we would have 6, 8, 10. Likewise, if I had 4.5, I would know that I'm multiplying by 1.5, right? So 3 would become 4.5, 4 would become 6, 5 would become 7.5. So they're going to be proportional. However, one side gets scaled up, the whole thing gets scaled up the same way. And a lot of the time, the way that you're going to end up dealing with this is by just setting up a fraction equal to a fraction, or at least that's the way that I like to do it. So if we didn't know our Pythagorean triples and we weren't good at just doing stuff in our head, let's make it hard, actually. Let's say we have a weird side length here. We have a 10, and we're trying to figure out what's the length of the hypotenuse here. What we could do is we could set up a proportion. We could say the smallest side divided by the smallest side is equal to the smallest hypotenuse divided by the target hypotenuse, the big hypotenuse, right? And then from here, we could literally just plug this into Desmos, or we could cross multiply, right? 10 times 5 is 50, 3 times x is 3x, and then our answer ends up being 50 over 3, which I don't think can be simplified. So there's a little example of how you might set things up. One more important thing to note about similar triangles is the way they look, because sometimes they're going to tell you that you have similar triangles, but other times you just have to figure it out based on the information they give you. Now, there's always going to be a bunch of text, but visually, they're always going to look the same. So I will just tell you what to look for visually. Anytime you have a right triangle inside of another right triangle, like this, for example, they are going to be similar. And we can see this, right? This is a right angle. This is a right angle. This is literally the same corner. And then these are going to be the same angles. So these two triangles would be similar triangles by definition. There's also a really cool one where they'll draw a straight line from one of the corners straight down. And this actually creates 3 similar triangles. We have the whole triangle, and then this triangle is similar, and then this triangle is also similar. So just remember, right triangle inside of right triangle means similar triangles. The one other visual clue that I've seen them giving is when you have a triangle coming out of another triangle, sort of like an hourglass shape. These don't necessarily have to be right triangles either. So if we had something like this, these guys by definition are going to be similar because we have this vertical angle. And in case you didn't know, angles that touch tips like this are congruent. And then your catty corner angles are also going to be congruent. So these guys would line up with each other, and these guys would line up with each other. So that's the other visual indicator of similar triangles on the SAT when they're not actually just straight up telling you that they're similar triangles. You've also got your special right triangles, and luckily this is also going to show up on the cheat sheet, which is nice. And your special right triangles are going to be your 30, 60, 90 triangle and your 45, 45, 90 triangle. And the reason that these triangles are special is their sides have a special relationship, which is for the, we'll start with the simple one. For the 45, 45, 90, if you do want to try to remember it and not have to look at the cheat sheet, I always think 2 similar angles, 2 similar sides, square root of 2. We have x and x, so your 2 legs are going to be congruent, and then the hypotenuse is x times the square root of 2. And then for the 30, 60, 90 triangle, I always remember 3 different angles, 3 different sides, square root of 3. And our shortest leg is going to be our x. And we know it's the shortest leg because it's across the street from the shortest angle, right? Sometimes they will draw it in a way that you can't tell as easily. So just remember, across the street from our 30 degrees is our shortest one. And then the hypotenuse is going to be 2x. And then the other leg is going to be x times the square root of 3. And as far as remembering which one of these is 2x, I always just remember the hypotenuse has to be the biggest, right? What's bigger, multiplying x by 2 or multiplying x by the square root of 3? It's going to obviously be multiplying x by 2. So that's how I remember that one. And the great thing about this is we don't even have to know 2 sides in order to get the third. If we know that we have, let's use our 30, 60, 90 triangle. If we have a 30, 60, 90, let's say they just give us the 60. By definition, we know the last one's 30. And let's say they just give us the hypotenuse. They're like, this is 10. What is the length of this leg? Well, we follow our little rules. We know that this is going to be our quote unquote x. This is going to be our quote unquote 2x. And this is going to be our quote unquote x root 3. Let's call it y so that we don't get confused here. So if this is y and this is y root 3 and this is 2y, then 2y equals 10, y equals 5, and then our target is going to be 5 root 3. So that's the magic of special right triangles. And then tying into what I said earlier, I mentioned that equilateral triangles have a really cool thing about them that we were going to go over later. So let's pretend that this is drawn perfectly, and we're told that this is an equilateral triangle. Remember, equilateral triangles have all the same sides and all the same angles, which means all of their angles have to be 60 degrees. So let's say we are given that this is an equilateral triangle, and we are asked for the area of this triangle. And the only information that we get is that each side, the base of the triangle is 6 feet. So how the heck do we find the area? Because we're supposed to have our height, but we don't have the height. Well, the cool thing is if we draw the height, we are splitting. Well, first of all, we're creating a right angle. We already know that this is 60 degrees. So boom, this has to be 30 degrees. And now all of a sudden we could say, okay, well, if this is 6 feet, then this smaller triangle is 3 feet on the bottom, which means this hypotenuse is 6 feet, and our height is 3 times the square root of 3 feet. So then to get our area, now we have a base and a height, right? Our base is still 6 feet, because that was the whole triangle, and then times 3 root 3, all of that divided by 2, and you can kind of simplify from there, right? Oh, sorry, we can't see that. So that's how you can sort of combine your knowledge of the triangle types and then the special right triangles. This is something that's pretty common on the SAT. But again, at the end of this video, I'll link to another video that has some actual SAT practice questions you can work through. And then the final concept that you need to know that is not on the cheat sheet is SOHCAHTOA. And a lot of you might have this memorized, but even of those who have it memorized, I've got a lot of students who I know just forget what to do with it. So let's cover this real quick. Starting with our SCA, they all stand for sine, cosine, and tangent, which are usually abbreviated as sin, cos, tan. And then the 2 letters that come after are going to refer to a fraction. O means opposite. We'll say op for opposite. H means hypotenuse. We'll say hype. So, and to be clear, these all refer to right triangles. And what we're doing is we're figuring out the ratio of one side to another based on an angle. So if we have, for example, angle X here, opposite is going to mean across the street. So we'll just go with another 3, 4, 5. And then hypotenuse is obviously the hypotenuse. So the sine of X for this triangle that I made is going to be 3 divided by 5. Opposite over hypotenuse. We'll use this same triangle to exemplify the rest of them. If we're talking about cosine, A means adjacent. We'll just say ADJ over H, which is again hypotenuse. So adjacent would be just right alongside. And you might be saying, well, this one's alongside and this one's alongside too, but the one that's not the hypotenuse, basically. So adjacent would be 4, and then the hypotenuse again is 5, is going to be 4 over 5, right? Tan of X would equal 4 over 5. And then finally, for tangent, we're going to have opposite over adjacent for A. So the opposite would be 3. So tan of X would be 3 over the adjacent, which is 4, 3 over 4. And that is SOHCAHTOA. Here, they tell us we have similar triangles, and it tells us that sine of n is 5 over 13, which makes sense, right? Opposite over hypotenuse. So yeah, of course it is. What's the value of sine of r? Well, if they're similar, they share the same angles, and no matter what the actual lengths of this triangle are, if it's bigger or smaller, it's still going to simplify down to the same exact fraction. So 5 over 13 is our answer. Go ahead and try this one on your own first if you'd like. Sorry you can't see choice D. There it is in case you're curious. But let's do it. Very similar to last time. We have more similar triangles. I was asking about SOHCAHTOA. So if it says A corresponds to D, basically this is our angle A, this is our angle D, which means C and F are going to correspond with each other. What is the value of sine of D? Kind of weird that they have the X right here, but whatever. The sine of D is going to be the same thing as the sine of A. So the sine of A would be 3 over the hypotenuse. And this is not a Pythagorean triple, so we would basically have 2 squared plus 3 squared equals this hypotenuse squared. But yeah, opposite over hypotenuse, it should be 3 over our hypotenuse. 2 squared is 4, 3 squared is 9, 9 and 4 is 13. So 3 over the square root of 13. Of course, they don't want us to have a square root in the bottom, so we'd multiply by the square root of 13 over the square root of 13 to get 313 over 13. Where is that? Choice C. All right, this is kind of a cool conceptual question where we're trying to figure out what would make the 2 triangles similar. So they're already telling us that they're right angled, so they share at least one angle, right? And DE is going to correspond to PQ, So the most helpful thing would be to just straight up tell us another angle, which I'm not seeing here. As far as the length of one line being twice the length of another, that's not necessarily going to prove that they're similar. If they were similar, we would have some sort of a proportional relationship, but choice A and D are going to be out. If they tell us just one angle, that's not going to work. So it has to be choice C by default. But let's go ahead and think about why this is correct. If the sine of QRP is equal to the sine of EFD, they already told us that DE corresponds to PQ. So everything is lined up there. And like we went over in that other problem, all of our SOHCAHTOA stuff is going to be the same if we have similar triangles. So that's, straight up proving that these are indeed similar triangles. All right, go ahead and try this one on your own first, but here we go. So, all right, we've got an isosceles triangle, and it's telling us our degrees here, 120, which means by default, both of these guys are going to have to be 30. And immediately, before I even know the question is, I'm like, well, let's cut this thing in half, because now we have 90 degrees, 120 divided by 2 is 60, and we've got 30, so we have a 30, 60, 90. It tells us that the distance from C to AB is 3, so it's telling us the distance of that line that I just drew. That means CB is going to be 6, because that's 2x, and AB, the distance between A and B is going to be 3 root 3 plus 3 root 3. So 6 root 3. So choice C here. And again, if this stuff is not making sense, you do need to watch my first video where I explain these rules. In this video, I'm really just going through and using them to solve actual SAT questions. All right, go ahead and try this one out on your own first if you'd like. But basically, we have two sides, and we need to know the third side, which happens to be the hypotenuse. I'm not recognizing this as an obvious Pythagorean triple that I have memorized, so I'm just going to use the Pythagorean theorem real quick. And I'll grab Desmos to do that, because why not? A squared plus B squared equals C squared. So in this case, it would be 12 squared plus 35 squared is going to equal this. And then that number, whatever the square root of that is our answer. What was that? 1369. I guess we could also do square root and then throw these guys under it, since we know that that's going to happen. And yeah, it's 37. So our answer is 37. Here's another one pretty similar. I'm not going to show you the other answer choices, because you shouldn't need answer choices. This is pretty straightforward. We're trying to solve for a third side when we already have two sides. So in this case, our hypotenuse is known. So it would be 6 squared plus b squared. I'll just call it x squared so that Desmos gives me the answer, equals 10 squared, or 100, right? And this is going to give us our answer right here, 8. You could also recognize this as a 3, 4, 5 triangle. This is a 6, 8. Oh my God, why is that so thick? A 6, 8, 10 triangle. I told you they show up a lot. All right, this is kind of a fun challenge because it includes a square. So we're going to need to know at least a little bit about squares to do this. But let's see if we can figure out what's going on here. Basically, they're telling us 6. They're telling us this is isosceles, and then we're supposed to figure out the area of the square. So I need to know one of the side lengths in order to get the area of the square. The cool thing is, if this is isosceles, the cool thing that I want to do here, at least I think it's pretty cool, is to just draw this all the way across. This diagonal is going to be 12, right? And now we have a 45, 45, 90, because obviously this is 90 degrees. So I can figure out the length of NO, LO, just using special right triangle rules. So 45, 45, 90 is going to be x, x, and then x root 2. So basically, x root 2 is 12. So x times the square root of 2 equals 12. And I could solve for that, or... So I know that each of my sides is going to be just, x equals 12 over root 2. Obviously, we would want to stick the root in the numerator if this were the answer we were going for, but we're supposed to figure out the area, which is just this squared. So this squared, well, 12 over root 2 squared. We square the numerator and the denominator. 12 squared is 144. Square root of 2 squared is just 2. 144 divided by 2 is 72. So our answer is 72. This is a fun one because it's a triangle question, but where's the triangles? I see a square and a circle. Try it out, but pretty much we know that a square is 90 degrees all around, and it's asking us about the radius of the circle, which is going to be kind of like this, right? So that isn't something I can play with by itself, but if I drew it all the way across, now all of a sudden I've created a 45, 45, 90 triangle. The side of the square is 8 centimeters. That means that my diagonal there is going to be 8 times the square root of 2, and half of that would be my radius, 4 times the square root of 2. So my answer is 4 root 2. Go ahead and try this one out on your own first, but here we go. So they're asking us the area of the triangle in square feet, and then they're also giving us conversion, which we should probably know, but the info that they have is in inches. I'm just going to draw this out real quick to make sure I'm not completely lost. And it says in a right triangle, well, I've already screwed up. In a right triangle, this will make things easier because remember, if we have a right triangle, then we have base and height as our legs. One side measures 48 inches, so 48 inches, and the other measures 30 inches. And it says which is the height from the base, but I don't care. We just pretend we flipped it on its side, right? Doesn't matter. It's arbitrary. But we want to convert that into feet. So there's a couple things we could do. We could either calculate this and then divide by 12 squared, because remember, because we're talking about square feet, not just feet. Or we could convert this to feet and then just calculate it. I think I'm going to go the first route. I'm going to get my my area, and then I'm going to divide by 12 squared. So I'll grab it Desmos because why not? And we have, BH divided by 2 is our formula. So we would have 30 times 48 divided by 2. And then that would be our area in inches. But then that needs to get divided by 12 squared, which will give us 5, which is our answer. All right, just visually, we can tell we're dealing with similar triangles, right? We've got a triangle within a triangle. And it looks like they're giving us some information that we already have visually. So let's just jump to the main question. It says the area of PQR is 720. So that's the big one. So PQR is 120, and 720. I don't know where that 1 came from. And we also know that the area is going to be BH divided by 2. So let's figure out QR, because that would be our height, right? So basically 720 is going to be equal to 60 times QR over 2. So it'll be, and just to show you the power of Desmos here, we could just plug in X for our QR. So 720 is equal to 60x over 2. And that's actually going to just give us our answer. So 24. So now we know that QR is 24, the whole thing, that is. And then it's asking us the area of SQT, which is the smaller triangle. So now we just need to use a proportional relationship. So we can tell that the smaller triangle is 3 times smaller than the big triangle. So we already know that our base would be 20. And then 24 divided by 3 is going to be 8. So it'd be 20 times 8, because QT is going to be 8, divided by 2. That's the same thing as 10 times 8, which is just 80. So our answer should just be 80. All right, I'll show you the answer choices in a second, but try this one on your own first. If you watched my other video, you should be able to get this in about 1 second. Yep, it's 103, because the exterior angle theorem tells us that this angle is going to be equal to these two angles. 40 plus 63 is 103. We can use the exterior angle theorem for this one as well. So First of all, we need to know that this is a vertical angle. So this right here is also going to be 85. And then remember, the external angle theorem says any outside angle like this is going to be congruent to the two inside angles that are opposite it in a triangle. So 85 plus 35 is going to be 120. Here's another conceptual one. See if you can figure it out. Pause the video, try it on your own first. But they're telling us basically that we have these triangles, and that angle A is going to match D, angle C is going to match F. So we know that they're similar already, right? We also know that AC is parallel to side DF. What additional information is needed to prove that they are congruent? So exactly the same. Basically, we need two matching sides to be equal because otherwise they're just going to be proportional. So AB being equal to EF would not work because AB is the beginning of the triangle and then EF is the end. Likewise, BC is the end of this triangle and DE is the beginning of this triangle, just kind of like looking where things match up. D says side AC is equal to DF. Those guys actually match up. So that would be our answer. All right, let's end things with one more conceptual question. Take a look here, see if you can figure this out. There is a simple rule to this, again, mentioned in the video that I have linked in this video where I go over the rules, which is any two sides combined of a triangle are going to be larger than the third side. And I guess likewise, any side of a triangle is going to be less than, shorter than the two other sides combined. So what we can do is we can look at our answer choices and we know that 6 plus 8 is 14. So AC is going to have to be less than 14. So 15 is out and 14 is also out. But now we have 12 and 2. So what gives? We can't have two right answers. Well, we have to start thinking about the other sides, right? If AC was only 2, then 2 plus 6 would be 8, and then this third side would not be following the rules. So it's going to have to be 12 for that reason. I've compiled 35 hard SAT math questions to help boost your score. These questions do not show up on any of the Blue Book practice exams, so there's not going to be any spoilers, and I made sure to include every single type of math question that you'll come across on the SAT. Let's get started. All right, first one here. It's asking us about the value of x plus 6, and it gives us a little equality here. And there's a couple of shortcuts for this. The first one would be to say, if they're asking me about x plus 6, I can just pretend that x plus 6 is my variable. So I could say, for example, x plus 6, we're just going to say that actually equals y. So instead of x plus 6 over 13 and x plus 6 over 3, we could have, y over 3 equals y over 13. And that's one way to think about it. But if you look at this, there's also just a pretty obvious answer, which is what in the world could possibly be in the numerator and have two different denominators and still be the same number? No matter what number I put in there, it seems we're going to have different numbers, right? If we had 1, it'd be 1 over 3 versus 1 over 13, 2 over 3 versus 2 over 13. They're all very different numbers. The only number that's actually going to work would be 0. So we know that x plus 6 equals 0, which would be between -2 and 2. So it would be choice B. Alternatively, we could just plug this into Desmos, just in case that didn't, become apparent to you. So again, we could just do y over 3. Since we know that x plus 6 is the thing that we're solving for, we just say, well, let's just solve for that instead. And then it's at 0 because 0 is our answer. So a couple different ways to go about that one. But yeah, B is going to be our answer. All right, make sure to pause the video and try this on your own first. So anytime we are dealing with no solutions, two things are true. Thing number one, you have the same slope. So I like to get these looking more like each other. So I would expand the right side into AX plus AB. And if we have the same slope, well, our slope is 9. The coefficient for X is our slope. Here, the coefficient for X is A. So we know that A equals 9 because they have the same slope. So number one is definitely going to be true. The other thing about no solutions is that the y-intercept is not equal, because otherwise you would have infinite solutions. So we know that 5 cannot equal AB. So 5 is not allowed to be equal to AB. And since I know that A is 9, we know that 5 cannot be equal to 9B. And if we were to isolate B, we would divide by 9. 5 over 9 cannot be equal to B. So we know that 3 is true. Number 2, B equals 5. That doesn't have to be true. We could set B equal to 5 and everything would still be fine. So our answer is going to be 1 and 3. All right, pause the video, try this on your own first. So anytime that you're dealing with a table and you're being asked about something that can be seen visually on a graph, or something like the slope, we've got a new shortcut since 2025 with Desmos. So we're going to plug in a table, and you can type the word table. Ta-da! And the great thing is, if it's just a line, we don't even need all of these points. We literally need just 2 points. So I'm just going to put the first 2 points in here. Negative 11, negative 10, 18, and 21. And then I'm going to hit this little guy right here. Let me expand so you can see better. I'm going to hit this little guy right here for linear regression. And boom, it gives us our line so we can visually see things that we're looking for. It also gives us the slope in case we're being asked about the slope. But in this case, it says, what is the x-intercept? X-intercept, negative 4, 0. That's our answer. Pause the video, try this one on your own first. But here we go. There's a really cool shortcut for these types of questions. In particular, I'm talking about when we're asked about an increase. If we're just being asked about an increase and we have a linear equation, which we do here, right? We don't have x squared or anything raised to the x. So this is a linear equation. The trick is we don't care about the y-intercept because remember, the y-intercept is basically our starting point. That's going to exist no matter what. So if we're just being asked about an increase, all we care about is plugging in x, multiplying that by our slope, which actually represents our constant rate of change, our constant increase, and that's our answer. So what I'm going to do is I'm going to ignore 32. I'm also going to ignore this number because it's going to get added to 32. And all I care about is 9 over 5x. And it says we want to increase by 2.1 kelvins. So I will pull up Desmos. I will say, hey, Desmos, what is 9 over 5 times 2.1? 3.78. And that's all I care about. So that's my answer. All right, go ahead and try this one on your own first. But here we go. So x equals 2. Anytime we have x equals something, that means it is a vertical line. And I can show you this too. And if you didn't know this, you could just plug it into Desmos real quick. And you were like, oh, vertical line. And a vertical line, if we think about rise over run, it's going to be how much a line goes up and how much a line goes over. So this line goes up for infinity. So our numerator is like, what is the infinity symbol? It's like a little 8. Just looks like an 8. But anyway, the denominator, it doesn't go over at all. So the denominator is 0, which means this is undefined. But it's not asking us about a parallel line. It's asking us about a perpendicular line, which is the negative reciprocal, which would be, the infinity sign is supposed to be a sideways 8. That's why. Okay. Anyway. But the perpendicular to this would basically be if we had 0 over infinity. 0 over infinity. I know, it's a very ugly infinity. And then, in that case, our slope would be 0 because we are allowed to have 0 in the numerator. And technically, it'd be negative 0 over infinity. But, negative 0 is still just 0. So our answer is A. All right, pause the video, try this one on your own first. but here we go. So you could plug this into Desmos, but you end up getting some numbers that are not whole numbers and it's not super friendly. I would say if you can see that you're dealing with fractions in your answer choices and they're not really clean fractions, like, I don't know, 1/2 or something like that, you're probably better off not using Desmos. And in this case, they're talking about an x-intercept at a0. So we can just plug 0 in for y, which makes this disappear. And then we get 7x equals -31. So then x equals -31 over 7. And then for the other one, it's basically the same thing, but the y-intercept. So we could plug in 0 for x, and then 2y is going to equal -31. So then y equals -31 over 2. And now we just need the value of b over a, which would be -31 over 2 divided by -31 over 7. So first of all, if we have two negatives being divided by each other, we can get rid of the negative sign, right? That'll become a positive. So I'm just going to turn them both positive. And then if you want to divide fractions, you just multiply by the reciprocal. So remember, b was going to be our numerator. That was 31 over 2 after I turn it positive. And then to divide by 31 over 7, we multiply by 7 over 31. And then since 31 shows up in the numerator and the denominator, we can cancel that out. And we are left with our fraction, 7 over 2, which is our answer. All right, try this one on your own first. But here we go. I think I mentioned earlier that if you have no solution, the first thing that's true is that you have the same slope. So that's right. A equals 2 because our slope is 2. Easy as that. Try this on your own first. But here we go. This is almost exactly the same as the last one. We have no solution, which means same slope. 1 over half x. That means c is 1/2. All right, pause the video. Try this one on your own first. So for this one, I like to just use Desmos for inequalities most of the time. And we just will straight up put the inequality in there. So y is greater than 2x minus 1. 2x is greater than 5. And it's asking about all the y coordinates that satisfy the system of inequalities. So just to make sure we're on the same page as far as what a solution is, it's wherever you have a crossover of colors. So we got the purple, we got the black, and then we've got this place where they both touch. So these are all of our solutions. If it's asking about y values, then basically we want to know, like, what are all the y values that would be in here? And we can see this point right here where it starts is 2.5 and 4. So everything above 4 is going to be the y values that work. So it's going to be choice B. If you weren't too clear on the visual there, you could also start plugging in answers. So if we did like y is greater than 6, then we can see that there's this little portion that's not included. Like, hey, let me in. But then if we change it to y is greater than 4, it's like, oh yeah, that covers everything. So our answer, y is greater than 4. All right, pause the video, try this on your own first, but here we go. So this is a linear equation, and a couple different ways to deal with this. Let me give you the more formulaic way. So we know that y equals mx plus b is our basic, linear equation. And in this case, we know that Ken earned $8 per hour for the first 10 hours of work this week. So that $80 is going to be there no matter what. That's our starting point. That's B. And we know that he was paid $10 per hour. That's our constant rate of change after that. Because it is asking about the number of hours he needs to work the rest of the week. But it's also including that first 10 hours of money. So our answer for X is going to be hours, but our money is still going to include the first $80 that he made. Now, the issue is Ken only saves 90% of his earnings. So all we would have to do is take this and multiply the whole thing by 0.9. And then, since we're trying to save 270, we could set that equal to 270. And here we could plug this into Desmos. And yeah, we could obviously solve this out, but I like to throw stuff into Desmos whenever possible because not all of us are great at doing math on paper or mental math. So if you have 270 equals 0.9, 10x plus 80, then we're going to get our answer, which is 22. And then another approach that you could take is more of a back solving approach where you plug in the answers to kind of see what works. So we would still need to know that we're going to have 80 bucks no matter what. So then we would need an additional, because we have 270 that we're trying to save, minus the 80 that we already have, we're trying to get an additional 190, right? So we could take our answer choices and start plugging them in and just making sure to multiply by 0.9 so that we know there's only 90%. So if we started from the bottom, since we're trying to get the least number, we would start with the lowest number, right? So we would have 16 times $10 an hour times 0.9, and we would see that that's only 144. But then if we change that number to 22, then all of a sudden we got 198. Remember, we were just aiming for 190. So that's another approach that you could take if you didn't want to do the formulaic version. All right, pause the video, try this on your own first, but here we go. So this is asking about factors of a polynomial. And if you remember, factored form of a parabola is going to be y equals a times x minus p times x minus q, where p and q are x-intercepts. And this is factored form. So basically, when it asks about a factor of p, it's asking about what are the x-intercepts of p. And we can see those because x-intercepts are where y equals 0. So we've got one here, which is -1. And we've got one here, which is +2. Just remember, because our factored form is x minus p, x minus q, and this carries over for bigger polynomials too, not just for quadratics. It's always going to be the opposite of what's in parentheses. Our factors would be x plus 1, because we changed that negative to a positive, and x minus 2, because we changed that positive to a negative. And then that's going to be choice D, which is our answer. All right, go ahead and try this on your own first. But here we go. We have this exponential function, and it's saying we want the population of the city to decrease by a fixed percent each year. Which of the following must be true? So our basic exponential equation, the very most basic, I would say, that we can think of is going to be something like y equals a b to the x, where a is our initial value, b is going to be our percent increase or decrease, and then x is going to be the time. So in parentheses, we want to see our increase or our decrease. So if we have a decrease, r is going to have to be negative because we want 1 minus something to make this negative value in parentheses. So r cannot be greater than 0 or greater than 1. So both of those are going to be out, right? Because we want r to be negative. Now the issue is choice A and B, r is negative in both of them. So we have to kind of think about what would happen. If r was less than -1, what would happen to our population? Well, let's do a little experiment. Let's pretend that we have a population of 1,000. If we throw that into Desmos, we have 1,000, and then we would have 1 plus, what's a number less than -1? We'll just say -2. And then we raise that to the y, and let's just say, I don't know, we'll say what happens after 3 years? Well, it looks like we have a negative population. After 4 years, we have a positive population. After 5 years, we have a negative population. So you see how weird things can happen because we're going to be going back and forth between negative and positive. So that's super weird. But if we go between -1 and 0, so if this is negative like 0.5, now, no matter what happens, we still have a positive population, which is, makes a lot more sense because you can't have a negative population. So logically, choice A falls into some issues, whereas choice B, you're going to reduce the population, but you're never going to go below 0. So choice B is our answer. All right, next question here. Go ahead and pause the video and try it on your own first. But here we go. So I like to start with the main question anytime we have pretty much more than a single sentence. And it's asking for one possible one possible value of A so that these guys equal each other, right? So straight up, it is saying that they equal each other. And keeping in mind here that f of A and g of A is really just f of x and g of x. So it's really just asking for a value of x. So it might look like a, quote unquote constants question, but really it's not really a constants question. So I'm just going to pull up Desmos because it says such that they are equal to each other. So I'm just going to set them equal to each other. So f of x is going to be that equation there, right? So we have negative 1/2 x minus 4 squared plus 10. Whoa. Oh my goodness. Negative 1/2 x minus 4 squared plus 10. And we want to set that equal. There's actually two ways to do this. So I'll show you both. We could set that equal to negative x plus 10. And that'll give us our two options, right? 2 and 8. Alternatively, we could set them on different lines. You might want to do this because sometimes visually the straight lines are not quite as clear. But if we did y equals, and I don't think it'll let me copy and paste here. Oh, it will. I don't think that actually works on Desmos on the exam though, so don't count on it. And then y equals the left side, y equals the right side. Basically, we just put both equations in. And then again, we're just looking for points where they intersect. So we would have same thing, right? 2 and 8. And in this case, I think the other way is a little bit better because here we can see the y values. Luckily, they're the same, so we don't really run into an issue. But if we're just looking for the x values, then setting them equal to each other, in this case, is going to be a little bit more straightforward. So yeah, either 2 or 8. I'll go ahead and put in 8. So pause the video, try this on your own first. Then here we go. We got another single variable equation. That is to say there's only x, there's no y. And yeah, Desmos is the way. SQRT for square root, 2x plus 6 plus 4 equals x plus 3. And our answer should be 5. Boom. All right. Pause the video, try this on your own first. But here we go. So this is asking us the value of P. And there's a bunch of stuff on the left side that we could unpack to get it looking more like the right side. But if we can get away with a bit of a shortcut, I would like to. So what I'm noticing is on the left side, we have P being multiplied by X, right? And we have P being multiplied by X here. So it seems like P is only ever going to be attached to X. So rather than foiling out this whole thing, I'm only going to foil out the coefficients of X. So 3 times P would be 3px. And then keep in mind we're subtracting 16 times X would be 16px. And that's minus 16px. And I can't just pull that out. I have to pull out every coefficient of x. So there's going to be one more. When we multiply 16x times 4, it would be minus, what is that, 64? Minus 64x. And all of that is going to be equal to all the x's on in the other equation, because it says they're equivalent expressions, right? So that's going to be all equal to negative 155. Beautiful. So from here, the first thing I would do is get rid of my x's because we have x's attached to everything and we're trying to solve for p. So I'll just say goodbye x's. And now, if I want, I can actually just write this into Desmos. You know, for sure I could do the math and go that route, but I want to be as lazy as possible and make sure I don't make any sort of calculation errors that will cost me points. So all we have to do is make sure that we turn p into x, because Desmos wants you to use x. So we'd have 3x minus 16x minus 64 equals negative 155. And that'll give us 7. So our answer is 7. As always, pause the video, try this on your own first. But here we go. We are trying to look at this expression, which can be rewritten in this way. This is kind of similar to the last one. It's equivalent expressions, and the first step is always to get things to look like each other. So we would want to expand the right side. But again, just like with the last one, I really only want to figure out what A is. So anything that gets attached to A is going to be helpful. Now in this case, A is going to get distributed to everything. So I can really pull apart whatever piece of the equation I want. So I'm just going to arbitrarily go with this, the stuff that's attached to nothing. And in this expression, the only time that's going to happen is when we get 13a. So 13a is going to equal 1.17. And just like before, we can pull up Desmos, turn that a into an x. 13x equals 1.17. And it'll give us our answer, which is 0.09. Alternatively, we could obviously see that all we have to do is divide by 13. So we would have 1.17 divided by 13. And that can be written as a fraction as well, right? Which is 9 out of 100, 0.009. Either way, our answer is going to be 0.09. Okay, pause the video, try it on your own first. So this one looks pretty straightforward, and in some ways it is, but what makes it hard? I think it's going to be the fact that we have square yards, but the conversion they give us is not square miles and square yards. It's simply miles and yards, which means 1 square mile is going to be 1 mile squared equal to 1,760 yards squared, which makes a huge difference. So from here, basically, we just need to figure out how many square miles this is by using this conversion rather than this conversion that's not in square miles, right? So ignore that and focus on this instead. And now we can use dimensional analysis to make sure that we're keeping things in the right place. So if we have 11,863, 808 square miles, or square yards, I'll just call it y squared. We want to multiply that by 1 mile squared divided by 1,760 yards squared. And the reason that we know it's going to show up in the denominator is we need to get rid of yards and have only miles. And by having yards in the numerator and the denominator, they're going to cancel out, right? Sorry, those numbers won't cancel out, but the yards squared can cancel out that way so that we're left only with miles squared. So that's a little trick to make sure that you don't accidentally multiply when you should divide and vice versa. So we'll throw this into Desmos. And obviously this is just dividing, right? We're just dividing by this. It was 1,760 squared. And I think it's mad at me because I'm using commas. So let me get rid of those. There we go. And 3.83 is our answer. Just like that, we got our answer. All right, pause the video, try it on your own first. So we've got, it looks like, more than a sentence. So I'm going to start with the last question, which is, if she uses 5 ounces of blue paint for the second batch, how much yellow paint should she use? I kind of glance at the answers and I see the word ratio. So I know I'm dealing with ratio and proportion, which means we're usually going to have some sort of a fraction equal to a fraction type scenario. She created a batch of green paint by mixing 2 ounces of blue, so 2B to 3 yellow. She's going to use a second batch using the same ratio, so they will be equal. She uses 5 ounces of blue, and then she's going to use some unknown amount of yellow. And just for the sake of not confusing myself, I'm going to get rid of these letters, but let's just remember that our numerators are blue and our denominators are yellow. And then looking at the answer choices, it says how much yellow paint should she use? So you might be thinking, oh, we're going to solve for X. But then when we look at the answer choices, we have these comparison answers, right? 3 ounces more, 1.5 times more, 1.5 times this. So we could definitely just throw this into Desmos and get X. In fact, let me show you that real quick. No, we could also cross multiply, but again, if you want to, you can always just 2 over 3 equals 5 over X. Then we know that X is going to equal 7.5. We can also just look at this and we can see that in order to get from 2 to 5, we had to multiply by 2.5. So then 3 times 2.5 would be 7.5. Anyway, so X is 7.5. But then as we start looking at our answers, we can get rid of this. 3 ounces more than the yellow paint from the first batch would have been 6, so that doesn't work. 1.5 times the yellow paint, no, because we know it's 2.5 times the yellow paint. And then we get 1.5 times the amount of blue paint. And that we actually could have stolen from the first batch because it already told us that it's the same ratio. So that jump of 1.5, because 2 times 1.5 would be 3, 5 times 1.5 would be 7.5. So yeah, our answer is going to be choice D there. And I just explained 3 different ways of finding that answer, but I do like you guys to have options, and I feel like they're all equally fast. All right, cool. Pause the video, try it on your own first. Here we go. So this is just as straightforward as it looks, but most of my students miss it the first time. The reason being is we have a really small percent, and they don't remember that to convert this to a decimal, we have to move the decimal over 2. So the number that we multiply 140 by isn't 0.001, it's 0.00001 because we have to convert it to a decimal. Throw that into our calculator and we get 0.0014 rather than the 0.14 that a lot of my students will accidentally type. And that is it. Pause the video, try it on your own first. Here we go. So I like to just turn words into math when I see this kind of a question. The first sentence says the number W is means equals 100%, 110% greater would be the number 2.1 because we have our original 100%, which would be 1, plus the 1.1, which is the additional 110%. So that's a total of 2.1. 110% greater than the number Z. That means W would be 2.1 times Z. Next sentence, the number Z is 55% less than 50. So Z, remember, is equals. 55% less would be 45% of 0.45. And then 50 is the number 50. And then it's asking us the value of W. So real quick, let's figure out what Z is. 0.45 times 50 is going to be 22.5. So we can sub that in for Z. So then we have W equals 2.1 times Z, which we determined is 22.5. And our answer is 47.25. Pause the video, try it on your own. Here we go. I'm going to start with the last sentence because there's too many words. What's the difference between the median percent of residents who earned a bachelor's degree or higher? Median percent and the median for all 50 states. So for these, so basically the difference between median for these 7 versus median for all. So for this 7, the median is just going to be the middle number, but keep in mind it would have to be the middle number if everything was in order. So basically you find your, for a list this small at least, this is the method I would use. If it were a large list, we'd do something else. But for a small list, you just cross stuff out. So the lowest number is 19.5, the highest number is 36, the next lowest number is 21, the next highest number is 35, next lowest number is 25, next highest number is 30, and then our median is 27.9. And then I don't see all 50 states here, so I'm going to look at the rest of this, and then median for all 50 states was this. So the difference would be subtraction, 26.95. Just to be careful, throw it in the calculator. Don't leave anything up to chance. 27.9 minus 26 and 0.95 is the difference. So our answer is B. All right, we got some protein. Pause the video, try it on your own first. And I'll start with the main question. Which of the following is closest to the predicted increase? That means we're actually looking at the line and not the dots. In total fat in grams, we can see that that's just our y-axis, for every increase of 1 gram in total protein. Okay, so basically it's asking us for the slope. Increase in y, that's rise, for every increase of 1 gram, that's our x, rise over run, rise over run. So we're just looking for the slope. And sometimes we can just visually see the slope. For this one, I'm not seeing any super nice intersections, but we can kind of eyeball. We kind of have like 10, 20, and 50, 30. So we could do rise y1 minus y2 over x1 minus x2 and get like an estimate that way. And I'll try to just do my best to guesstimate what y is because it's a tiny bit lower than what it looks like. So for this one, I'll just call it like, I don't know, 18. We'll say 18 minus 48 over 10 minus 30. Desmos is already open, so might as well. And we're getting roughly 1.5 or 3 over 2. So our answer is 1.5. All right, pause the video. Try this on your own first. If a caller last Monday who asked about his or her bill is selected at random, which of the closest is the probability? Which of the following is the closest to the probability that the customer also asked for repairs? So it's a probability question, which means we want to find our desired divided by our total. Desired being the desired option, and then the total being like the total population that we're choosing from. So our population is a caller last Monday who was asked about bill. So last Monday is not showing up, and then we can kind of see that's the whole chart. Asked about bill is this part. So this is our total that we're drawing from, 671. Also asked for repairs. Asked for repairs is going to be this bit right here, 48. So 48 out of 671. It looks like we have decimals, so we'll actually plug that into Desmos to convert it into a decimal. And that is 0.072. So 0.07 is going to be the closest. And that's going to be our answer. Pause the video, try it on your own first. You know the drill. To the nearest tenth of a percent, what percent of states with a state level sales tax do not have a state level income tax? So this is talking about percent, but it's kind of a probability question, right? We're going to do the same thing where we want to find our desired. So percent of states with a state level sales tax. So state level sales tax. State level sales tax is going to be this column here. That's our denominator. So 39 plus 6 is 45. Do not have state level income. state level income, no state income would be the 6. So that would be 6. And then plug that into Desmos and turn it into a percent. 6 over 45. 0.13333, that's going to be 13.3%. Boom. All right, pause the video, try it on your own. You know the drill. Here we go. Which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? Based on the wording here, it seems like another probability question, but this is like a word problem. But the number of 8th grade students in a state who have fewer than 2 siblings. So state with fewer siblings is going to be our denominator. And then 8th grade students from that population is going to be our numerator. So let's just figure out what these numbers are. 26 students were surveyed and 34.6% reported they had at least 2 siblings. That means the opposite of that, so whatever 100 minus 34.6 is percent would be the states with fewer than 2 siblings. So let's do that. We'll take our calculator, and 100 minus 34.6 is going to be 65.4. Turn that into a percentage, it would be 0.654. And that's 65.4% of the 26 students who were surveyed, which is around 17. And it does say estimate, so not having a round number is fine. So 17 students. And then it says best estimates the number of 8th grade students in the state. So now we have to project this to the entire state. So in the state, there were around 26 students. So this number 17, but an estimated 1,800 classes. So we'd have to take this number and multiply it by 1,800 to get all of the classes. And that is going to be 30,607. 30,600 is the closest. All right, pause the video, try this one first, but let's take a look. This is one of those questions where we're basically trying to figure out what can be determined based on a study or a survey in this case. And some things you want to keep in mind are that the best kind of survey is going to have a large random sample, and any sort of statement that we can make cannot be definitive. It cannot be absolute. We can't say something is absolutely true or not. We can only guess. So we want to look for sort of hedging language, if you will. For this, I basically just want to go through and eliminate. So A says the mean number of children per household in the community is 2.4. This is a definitive statement about the community. We could say something like is estimated to be, but that is not going to work. A determination about the mean number of children per household in the community should not be made because the sample size is too small. So, depending on how many people are in the community, this might be too small. But for now, we're going to hold on to that one. The issue is we don't know how many people are in the community, so it's hard to determine if it's too small. So I don't love that one, but we'll keep it because maybe. C, the sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. So sampling method is flawed. Remember, things that could make it flawed would be if it is too small or if it is not random. And here we do have an issue. At a playground is not random. If we're trying to figure something out about the community, we wouldn't want to survey people just at a playground. If we were trying to figure stuff out about people at playgrounds, then it could be a little bit better. But C is feeling better than B because it is an issue, right? People just at a playground is not random, so C seems good. D, the sampling method is not flawed. No, so it'll be choice C for this one. All right, pause the video, try this one on your own first, but here we go. We've got similar triangles, which means we have the same angles and all the sides are proportional. So it's telling us that this first triangle is 4 times bigger than this second triangle. It's giving us the area of the first triangle, and it's asking us the area of the smaller triangle. So the formula for area is going to be BH, base times height, divided by 2, equals area. So if we look at it, because similar triangles have corresponding ratios, the base and the height are both going to have increased 4 times. So if this was the formula for DEF, then the formula for ABC would be 4B times 4H over 2. So basically, when these guys get multiplied together, ABC is 16 times bigger, because 4 times 4 is 16, 16 times bigger than DEF. So now we just kind of have to work backwards with that in mind. So 270 is equal to 16 times the area of DEF. We'll just say 16A. And then 270 divided by 16 is going to be our answer. And as always, anytime you have a single variable equation, you could just write it as a little graph, or just use x, 16x, and your answer will pop up there. Or in this case, anytime we have a fraction, I like to just have the fraction. We know it's also 270 divided by 16, and we can simplify that to 270. Oh, that's it. 270 over 16. Is that it? No, 135 over 8. Okay, 135 over 8. And that'll be our answer. Go ahead and pause the video and try this one on your own first. But here we go. So a cube has a surface area of 54 square meters. So surface area is one of the things that we are not going to get from our reference sheet, unfortunately. What we do get is a rectangular prism. So we need to kind of think about this if we don't already have the formula memorized. So think of a die, and a die is a cube. How many sides does it have? It has 6, right? So if the surface area is going to be all 6 of those sides added up, then basically surface area is going to be 6 times the area. The area being the area of one of those squares that make up the faces of the die. And then our formula for area is just side squared, right? So if we think of side as S, then surface area of a cube is going to be 6S squared. S being like, here, I'll try to draw a really bad cube. If this is a cube, then one of our corners is our side, right? So that's what I mean by that. And now it's asking us, what is the volume? And volume, they actually do kind of give us the formula for that. It's just going to be side to the third. But if we look at this, then length times width times height, but we know that length, width, and height are all the same for a cube. So if we can find out S, then we can put that to the third, and then we'll get our answer. So 54 is equal to 5S squared. 54 divided by 6 is 9, so S squared equals 9, which means S equals 3. And then 3 to the third power would be 27. So our answer is B. Pause the video and try it on your own first, but here we go. It's giving us the length of BD as 6 and the length of AD as 8. Automatically, I'm recognizing a 3, 4, 5 triangle, or in this case, a 6, 8, 10 triangle, 3, 4, 5 being a Pythagorean triple. So I know that this is 6, 8, and 10. So AB is 10, and it's asking about DC. So we should be able to tell that these are similar triangles anytime you have basically like a triangle within another triangle. They're similar triangles. And I want to basically just put this smaller triangle, BDC, I want to put it in the same position as ABD. So if I were to lay it correctly, it would look just like ABD, like this. And then this corner here is D. That's our right angle. B is going to be over here. And then C is going to be up here. So if it's asking about DC, DC is going to be my shortest side. But in this case, BD, I still know is 6. And I know that it's a 3, 4, 5 triangle. So basically, if 6 is getting compared to 8 here, so basically, if we want a ratio of 3 to 4 between the smallest side and the next biggest side, we would have 3 over 4 is equal to x over 6. And we can cross multiply, or we can just throw it into Desmos real quick. I'll cross multiply since I haven't shown you that method in this video yet. So cross multiplication would be 4 times x equals 3 times 6. It's a little diagonal there. 3 times 6 is 18. 18 divided by 4, x equals 18 over 4, which could simplify to 9 over 2. So my answer should just be 9 over 2. And to be clear, 9 over 2 is 4.5, so we're all good there. As you can see, it's just the system, unfortunately, is not accepting more than one answer, but you can see that we did get the correct answer here. So we're all good. All right, try it on your own first. Here we go. This first part is basically telling us that it is what it looks like. These guys are indeed parallel, and we have straight lines and all that kind of stuff. So the question is, what do they want us to figure out? It says A equals 43. So this is 43 degrees. And then B equals 122. So this is 122 degrees. And we're trying to figure out the value of W. So I like to kind of play ring around the rosy and more or less figure out what I can figure out based on the information that I have. So one thing is a straight line is always going to be 180 degrees. So if B is 122, we can play ring around the rosy, and we can know that this right here is going to be 180 minus 122, which is 58. So this is 58 degrees. Vertical angles are congruent. So we know that this is also going to be 43 degrees. And then triangles have 180 degrees. So these have to add up to 180. So this would be 180 minus 58 minus 122. Or sorry, 180 minus 58 minus 43. So 79. And again, we know that vertical lines are 180. So if this is 79, this would have to be 101. So a couple of things that we know right off the bat. We also see that this is the same angle as this, and this is the same angle as this, because these are similar triangles. Again, that whole triangle within a triangle thing, right? So that means, I'll change colors here. That means we can pull this down, and we know that this is also 79, and this is also 101. And I'm just not even going to worry about this over here because we're trying to figure out what's going on with W, right? Vertical angles are equivalent. So this is also 79. And circles are 360 degrees. So W is going to be all of this stuff, 360 minus all of this stuff divided by 2. So I've got 360 minus 79 times 2 minus 101. And all of that is going to get divided by 2 because we would have our leftover, but then there's 2 w's, right? So 50.5 is going to be the value of w. Really? Oh. Oh, this time it even said 101 divided by 2 or 50.5, but it still said I was wrong. Yeah, so I do apologize if you do end up using this system. This is one issue that you'll run into with some of the questions is that it won't accept both versions of an answer. Other than that, it's a pretty cool system. All right, we got another triangle question here, and pause the video and try it on your own first. But here we go. So this one is also similar triangles, and they're telling us that one of the triangles basically is 2 times bigger than the other one. Now, in this case, we actually don't care. Anytime we're being asked about cosine or sine or tangent, the lengths don't matter because the cosine, sine, and tangent are always going to be the same. The reason is if you have a triangle, let's say we have like a 3, 4, 5 triangle, and then we had a 6, 8, 10 triangle, sine, cosine, and tangent are all based on proportions. So like if we're looking at this angle, the sine of this angle is going to be 4 over 5 because sine is opposite over hypotenuse. And the sine of this one is going to be 8 over 10, which would just get simplified to 4 over 5. So we can literally take the angle from the smaller triangle and apply it to the bigger triangle. We don't have to worry about how much bigger it is. So let's clear that up right off the bat. And now let's go ahead and draw our triangle. It says that C is a right angle. So this is C. We'll say this is A. We'll say this is, or say this is A, say this is B. So if tangent of A is 21 over 20, tangent SOHCAHTOA is opposite 21 over adjacent 20. What is the value of sine of D? D corresponds to A. So we're looking for the sine of A, which would be 21 opposite over the hypotenuse. And I recognize this as a Pythagorean triple, 20, 21, 29. You could also use the Pythagorean theorem to figure out this is 29, but the sine of A is going to be 21 over 29. And let's see if it actually lets me put that fraction in or if it's going to be a jerk. 21 over 29. Are you going to be a jerk? Yeah, it's going to be a jerk. But as you can see down here, it is indeed 21 over 29. So we're all good there. All right, next one here. Go ahead and pause the video. Try it on your own first. But here we go. This one is telling us the length of a rectangle's diagonal is 3 root 17. So we could draw a rectangle. We could have a diagonal that is 3 root 17. And then the rectangle's shorter side is 3. What is the length of the rectangle's longer side? So for this, we could just use the Pythagorean theorem. The longer side is going to be our unknown here. And we should know that 3 squared plus x squared is going to equal 3 root 17 squared. 3 root 17 squared is going to be 3 squared times square root of 17 squared, which would be 3 times 17. And I guess we could do all that, but I'd rather just throw it into Desmos, so I'll just throw it into Desmos. 3 squared plus x squared equals 3 root 17 squared. And then our answer should be this number here. Whoops, hold on. 3 root 17 squared, not 3 root 17 squared. Boom, there we go. And then our answer is going to be 12. All right, pause the video, try it on your own first. But here we go. We have a circle question, and it gives us basically the equation for this circle because our circle equation is x minus h squared plus y minus k squared equals r squared. R being the radius, h and k being the center. So in this case, we would have x plus 5, because remember it's the opposite because of the minus, plus y minus 2 These guys are both squared. And the radius is 9. 9 squared would be 81. So that's what we're looking at. But then they want us to unpack everything and stick the C value on the left side as well. We know that C is going to be everything that's not attached to X and Y, so we can kind of just ignore that part and only focus on the stuff that's not attached to X and Y, which would be 5 times 5, 25, plus -2 times -2, 4, minus 81 to get 81 over to the left side. We'll throw that in real quick. -52 is going to be our answer. Boom. All right, here, another circle equation. It's telling us that point P is on the circle. So basically point P, if we plug it in, it will indeed equal 16. And point P has these coordinates. It's asking about PQ as a diameter of the circle. What are the coordinates of Q? So one way we could do this is to graph it in Desmos and then just kind of take a look at our point and go from there just to get a nice visual. So let's do that. We'll go ahead and plug in our circle. And we already know that the center is going to be 6, -5. But let's take a look at that. We also know that our radius is 4 because 4 squared is 16. So there's our little circle. And then we could also plug in the point that they said is on the circle. And indeed, we will see that it's there. And because we have -5, which we know is the exact middle of the circle, since the center is -5, if PQ's diameter, it means it would go straight across. So right here on this side of the circle is going to be Q, which is 2, -5. Boom. All right, we got one more circle question here. This time, they're telling us about a circle with center O and AB lie on the circle. So we could say this is A, say this is B, and it's telling us that the measure of arc AB is 45 degrees. So basically, this slice of pie is going to be 45 degrees, which means this central angle is also going to be 45 degrees. And the length of AB is 3 inches. So 45 degrees is also 3 inches. What is the circumference of the circle? Well, we know that there's 360 degrees in a circle. So this arc is 45 out of 360. And that's always going to be proportional to the actual circumference of the circle. So 3 inches out of the entire circumference, x. And we can just throw this into Desmos. So 45 over 360 equals 3 over x. And x equals 24. Boom. Easy peasy. Moving into the math section, we've got interpreting quadratic equations. And when you're working on these types of questions, first of all, start with the main question so you know what you're looking for. Which of the following is the best interpretation of the vertex? All right. So we know from the start we're focusing on the vertex. Now let's also talk about what happens with a quadratic. So if you imagine a quadratic on a graph, typically you're going to get something like this, where you've got like either a smiley face or a sad face, right? You have a parabola. In the context of a word problem, it's going to be a little bit different. You're usually going to be throwing something. So imagine like you're tossing a ball up into the air, and maybe you're standing on a ladder, right? So it starts off up here, maybe the ground is down here, and then you throw a ball into the air and get that quadratic parabola curve. In the case of a positive parabola, which is usually going to look something like this in the context of a real problem, you basically have the scenario that's described here. You have something maybe like hanging from a rope, and then it swings in that parabola shape. So with that in mind, the vertex is going to be either the height, the maximum height if you're throwing something, or the minimum height if you're swinging something. In this case, we know that we're swinging something, so basically we're looking for the minimum height if we're thinking about the vertex. Choice A says the ball's minimum height, so we would keep that one. Choice B says the ball's minimum height, so we would keep that one. C and D just say height when it started moving, so that is not what we're looking for. And then we just have to figure out, was the height 3 or was the height 7? Well, this is actually in vertex form. So a little refresher, vertex form is going to be y equals a times x minus h squared plus k. And your vertex in vertex form is hk. Hk is the vertex where h is your x value and k is your y value, all right? Now, the one thing you have to remember is it's minus h in the equation. So if your h is a positive number, it becomes negative, and if it's a negative number, it becomes positive. So in this case, our vertex would be 7, 3, right? So our vertex is 7, 3. And height is rise, right? Up and down is your y, so that would be height. And then left and right would be your x. So since your y value is 3, your answer would be 3 inches above the ground, choice A. And while we're on the topic of interpreting things, we've got another interpreting question, but this one is for an exponential equation. And more often than not, and this is the reason this is a prediction that this is going to show up on your next SAT, is that more often than not, they want you to interpret the y-intercept or figure out the y-intercept of an exponential equation. So let's just talk about the exponential equation in general to start. Basically, you're going to have your total value, and then you're going to have your initial value. You're going to have some sort of percent increase or decrease, and then you're going to have your time, all right? And a little shortcut that we should know is if you're looking for the y-intercept, all you have to do is make x 0. So what is x? Well, remember your function on the left side is always going to be your y value, and it is function of t. So t is standing in for x. That means all you have to do is turn t into 0 to get your y-intercept. And then any time to the 0th power is 1. So basically, the y-intercept of any exponential function is going to be when you're not increasing or decreasing by any percent. It's literally just where you started from. It's your initial value, right? So in this case, it would be 8,000 times 1, so it's just 8,000. So what we could do is get rid of any answers that don't have 8,000. So A and C would be out. And then we want our starting point, basically, right? So we do want to read just a little bit of the actual problem to find out what our starting point should look like. So if we eyeball it here, it says T represents the number of years since the end of 1998, since the end of 1998. That means our starting point should actually be the end of 1998, which is exactly what we see in choice D. So our answer is choice D. Next up, we've got questions involving interest. And for these, we really just need to know, what is interest? Is it going to be something that increases or decreases? The most common context for this is going to be like if you get a loan. So let's pretend you buy a new car and you have to make payments on that car. Now, the car is originally like $20,000 and you're going to be paying that back for 5 years, but you're actually going to end up paying more than it was originally worth because you have to pay interest. So interest is going to be an increase in your original price. As long as you can remember interest is an increase, you should be good. Now, of course, you're also going to need to understand how percentages work. But let's take a look at the situation here. It is asking what is true about the investments, and all we need is right here in this chart. So let's just go through and start eliminating answers that are not true. So A says account A always earns more money per year than account B. So let's compare what happens here. Account A started with $500. But it's not talking about where we started with. It's saying what we earn every year. So this balance increase is what we are earning, right? So 6% annual interest, well, annual means yearly, right? So every year we're going to be getting 6% of whatever we have. So if we just look at that first year, starting with 500, to get 6% of 500, we just multiply 500 times 0.06. Because remember, 1 is like 100%, 1.00. So whenever you're thinking about percent, just think about that. 1.00 is 100, so 6 would be 0.06. You can obviously just throw that into Desmos, and that ends up being 30. If we look at account B, it's a lot more straightforward. It's just $25 a year. That's it. Well, $25 a year, 30 is more than account B. And if you think about the next year, account A's 6% is just going to keep getting bigger and bigger, because the second year it's going to be 6% of 530. And then it's going to be 6% of whatever the new amount is. So yes, account A always earns more money per year than account B. And because of that, we can only have one true answer. Which of the following is true? That means only one is true. Since we've proven beyond a shadow of a doubt that choice A is true, we know that's our answer. So let's not waste any more time. We'll move on to the next question. Next is comparing measures of central tendency. It's highly likely you're going to come across a question that asks you to compare mean, median, or mode. In this example, we're comparing all three. So let's quickly define these things. The mean is going to be the average. And in order to get the average, we take our total and we divide by the number of values. Median is simply the middle number. So if we were to take all of our values and line them up from smallest to biggest, the median is the number that's exactly in the middle if you have an odd number of values. Or if it's an even number, like we have in this case, it would be the average of the two middle values. And then the mode, which is usually the easiest, is just the most common value. So like in this case, we have to just go off of frequency. So the highest frequency, because frequency is just how many of them there are, that's going to be our mode. So we already know right off the bat that the mode is 18. So if it's asking us to give the correct order of the mean, median, and mode, we really just have to quickly figure out what they are and then put them in order. So we already determined that the mode is 18. The median is also usually pretty easy to find. If you have an actual list, you can just start crossing things out from outside to inside. Like let's say I had a list of 1, 2, 3, 4, 5. It would be pretty easy to go cross off, cross off, cross off, cross off, and then you land in the middle. But if you have a larger list, or if it involves frequencies like this, there's a different trick that you can do. You take your total and you divide it in half. So in this case, 20 divided by 2. If it's an odd number, you would end up with a decimal and you round up. So like, let's say instead of 20 over 2, we had 9 over 2, right? We would end up with 4.5, and then we would round up to 5. But in this case, it's an even number, which means we're going to take our answer and we're going to average it out with the next highest number. So 10 and 11. And to be clear, I'm not saying we're going to find the average of 10 and 11. We're going to find the average of the 10th value in the list and the 11th value in the list. So if we go from smallest to biggest, we have 6 18s, 5 19s. So this is already our first 11 numbers. So the 10th and 11th number are both 19, which means our median is also going to be 19. All right, so we already know mode is 18, median is 19. Now, finally, we've got our average, which we already know the formula for. And you could put this into Desmos and just have a list, but keep in mind, it would be a list of 20 numbers. So what would be easier would be just to write it out. And I'll show you a really nice way of doing this. So basically, we pull up Desmos, we've got 6 18s, right? So we can say 18 times 6 plus, so this is how we're going to add our values together. Rather than writing 18 6 times, we're just going to say 18 times 6 plus 19 times 5 plus 20 times 4 plus 21 times 2 plus 22 plus 23 plus 30. So then all of that is going to be divided by 20, since we have 20 in total. So then we know that our mean is 20, which is the highest value. So in order, we want mode, median, mean, which is choice A. And that's our answer. Next, we've got what I like to call percents into numbers, where they're going to give us a lot of percents. They're going to give us one number, and then we need to sort of extrapolate, all the actual numbers. So let's look at the example so I can actually show you what I'm talking about. Basically, it's giving us a chunk of percentages. It's telling us we have 15% parents, we have 45% teachers, we have 25% school and district administrators, and then the remaining 6 individuals are students. So right now, we need to figure out what percent do we have before these 6 individuals. 25 and 45 is going to be 70, plus 15 is going to be 85. So 85% is what we have before the 6 individuals, right? So we can figure out what percent the 6 individuals are. The 6 individuals are 15%. I don't know why I keep calling them individuals. They're students. So 6 is going to be equal to 0.15 of our total. Let's call our total X. So how do we get our total? Easy. Divide by 0.15. Pop that into Desmos. We got 6 divided by 0.15. 40. So now we know that our total is 40. All right. Now what it's asking us is how many more teachers were invited to join the committee than school and district administrators. Well, let's figure out what those percentages were. How many more teachers? Well, teachers were 45. School and district administrators were 25. So as far as percent goes, it was 20% more. So all we have to do is get 20% of 40. So we can jump back into Desmos real quick, and we could say 40 times 0.2 for 20%. And then our answer is 8. And make sure to pause the video and try each of these questions on your own first. So before we get into it, let's talk about what every part of y equals mx plus b represents in the context of a word problem. So y is going to be our total. X is going to be the thing that affects the total, which is usually time or a number of items being purchased or something like that. M is obviously the slope, but we want to look for a constant rate of change. Think like miles per hour. And then B is our starting point. So let's take a look at this question. And a nice shortcut is go ahead and just skip to the main question. That is usually the last sentence. Which of the following is the best interpretation of the number 2? All we have to do is figure out 2 is which of these? Is it Y, X, M, or B? So in this case, it's going to be taking the place of M, right? So we're going to look for a constant rate of change in our answers. A says the number of years it took. So a number of years is not a constant rate of change. So A is out. B says the average number of feet that the tree grew per year. So that is a constant rate of change. Probably our answer. The height in feet, height is going to be a specific number. Again, not a rate. The average number of years it takes similar trees to grow? No. So the only rate of change is B. So without even really reading the question, we know our answer is B. Next up, we have constant questions with infinite solutions and no solutions. This one says it has infinite solutions. Basically, this means that these two expressions are going to be exactly the same. One of the tricks with these is that you really don't need to worry about your leftover number that is not attached to X. So this 16 and this 8, if it's infinite solutions, they are going to end up being equal. But if it's no solutions, then these numbers would never end up matching up. Regardless, you can focus on what's attached to X and just make sure that those match up. So what do we multiply by to get 2x? We multiply by 2. So A is going to have to be 2. Let me show you one that has no solution so you can see what I mean. Same thing. We're just going to focus on getting something that's attached to x. So for this one, we're going to have to take an additional step and actually FOIL this out. B times x is going to be bx. I'm just going to write it over here. Negative 2 times x is going to be negative 2x. So we have bx minus 2x. And I was telling you that we don't want to worry so much about the number that is not attached to x. So in this case, it would be 8. What we do need to do is we need to move the 2x over so that the bx is by itself. So we're going to add 2x to both sides. Go ahead and draw this down here. And then we get bx equals 2x plus 8. And again, we do not need to worry about the 8 here. So we're actually just going to get rid of it. Basically, bx equals 2x. So it looks like, again, our constant equals 2 because they need to match up. Next up, we've got probability questions. And for these guys, we really want to just think about what does probability look like on the SAT. We're always going to have some sort of desired outcome divided by the possible outcomes. And let me give you an example here. Let's say I wanted to know if I flip a coin, what is the probability that I will land on heads? So there's only one head. My desired head is 1, but what's possible? There are 2 possible outcomes. There's heads and tails. So possible would be 2. That's a very simple and straightforward example. But if we can identify our possible and our desired, it really becomes quite easy. So if you haven't already, pause the video and try this question using that principle. But I'm going to go ahead and get started. So again, I like to go straight to the main question and kind of work my way and then decide what parts of the text I want to look at after that. It's asking me the value of x. So right away, I'm going to look and I'm going to see that x is, here in this chart. So I know that that's what I'm aiming for. Now, picking through the rest of the question, I can see that the first sentence is really just giving me facts that I don't need to know. I don't care what these things actually mean. I just want to focus on the numbers. And then the second sentence is describing the chart that I can see. So I also am going to ignore that. And what I really want to focus on is if one of these people who is rhesus negative. So that if statement, if one of these people who is, these phrases are indicating that this is my possible, because we're not talking about the entire chart. We're talking about one of the people who is rhesus negative. So where's my rhesus negative? Well, we see that this says rhesus right here. And then there's our negative. So basically my possible is going to be here. So before I do anything else, I'm going to go ahead and write my possible. We've got 7 plus 2 plus 1 plus x, or 10 plus x. We know that's our denominator. Okay, now let's figure out what our desired is. The probability that the person has blood type B. So we're going to pause there as well. We look at blood type B, and again, we're only looking at this part that I circled. Blood type B is 2. So we know that our numerator, our desired, is 2. Cool. And then finally it says is, a little trick for you. The word is means equals. That is how you translate that into math. Let me move this over. Is 1 out of 9. So this equals 1 out of 9. All right, now we've just got simple algebra. We can go ahead and cross multiply, which means we're going to multiply our diagonals. So diagonal from 2, we have 9. So 2 times 9 is 18. And this will be equal to our other diagonal, which is 1 times 10 plus x, which is still just 10 plus x. From here, we subtract the 10. And then 8 equals x, which means our answer is 8. Our next question type is scatter plots / lines of best fit. And there are 2 things that I want you to be careful of when you encounter these types of questions. Number 1, be careful and make sure that your y-intercept is actually your y-intercept, because sometimes that is not going to be the case. And the way to check for this is just to make sure that you actually do have 0, 0 in the corner here. In this case, we do have 0, 0. But for example, if this 0 were, I don't know, 20 or 30 or anything other than 0, then what looks like our y-intercept would not actually be our y-intercept. The other thing I want you to check for is to make sure that the x-axis and the y-axis are growing at the same rate. And sure enough, they are not. The x-axis is growing by 10 each slash, and the y-axis is growing by 1 each slash. Why is this important? Because if you try to just eyeball what's going on with the slope, for example, you're going to be in big trouble. All right, now that we've looked at that, let's see what's going on here. Basically, it gives us the equation, and then it asks us what's being predicted. So going back to those definitions we talked about at the beginning of the video, our constant rate of change should be 0.096, because that's where m goes, right? Remember, we're thinking y equals mx plus b. So that's our constant rate of change. And then our starting point is going to be negative 0.488, more or less, right? So now what we can do is just go through and eliminate any answers that are telling lies. A says each year between 1940 and 1910, so every year, now keep in mind this is going by 10 years, right? Each year, the average increase was $0.096. So let's kind of look at this. If we go roughly from here to here, that's about $1, right? And that's over the span of 10 years. So about $1 would be 0.96. If that happens in 10 years, then 1 year we would just move the decimal over one place, right? And we would get 0.096. So not only is that the constant rate of change that we were looking for, it also makes sense when we look at it visually. So we don't need to go any further. A is our answer. All right, our last type of math question I'm predicting will be on your SAT is a lines and angles based question. And for these questions, there are several concepts that you're going to want to know to sort of play ring around the rosy and get to your answer. For this one in particular, the first geometry rule I'm going to use is the straight line rule, which is basically a straight line is 180 degrees. And we always want to start with something we know to figure out something we don't know. I see that S as a straight line. So if on one side of this straight line, we have this angle that's 106 degrees, and we know that the full straight line, that angle is 180 degrees, all we have to do is take 180 and subtract 106 to get the missing angle. So that would be 74. So we know that this little angle right here is 74. Now we can use the same 180 rule, but the 180 rule of Triangles also have 180 degrees. So now we can go 180 minus 74 for this angle, minus 23 for this angle, and we get 83. So we know this angle down here is 83. And then one more time, we've got another straight line here. So 180 minus 83 is going to be 97, which is X, our answer. We've got questions that look like they're going to require the quadratic formula. So if we take a look at the quadratic formula, we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Because of this square root, a lot of the time you end up with square roots in your answer choices. So when we look at this, it seems like we might have to use the quadratic formula, which is a little bit annoying. And in truth, we could use the quadratic formula for this one. We could also use substitution, which is again going to be annoying, but there is a way that looks like it's going to be faster, and in this case it would be, and then there's a safer, fast way. Let me show you. So the way that looks really fast to me is testing out the answer choices. This strategy is also known as back solving. And the reason this looks very tempting is if we take the first answer and we plug it into the top equation, we get 1 plus the square root of 3 minus the square root of 3 equals 1. And that's definitely true, right? Because we're getting rid of the square root of 3, 1 equals 1. And if you were just testing the top equation, you would get lucky and you would answer A, because that does happen to be the answer. But the problem is, if you're being careful, which you should be, you get down to C and the same thing happens, right? You have 1 plus the square root of 5 minus the square root of 5. And yeah, that equals 1 too. So now at this point, we're going to have to plug them into the bottom equation, which as you can see is not going to be nearly as fun. So what would I recommend? Believe it or not, we can use Desmos on this. I know it doesn't look like it because of the radicals, but bear with me. If I pull it up and we go ahead and put in our system of equations, it is asking us which ordered pair is a solution. So if we can match one of the answers to one of our solutions, we should be good. So if we look at this one, we've got 2.732, 1.732. And from here, it's as simple as plugging in our answers to see what they look like in decimal form. So A, we've got 1 plus square root of 3. And by the way, I typed in SQRT, a little shortcut for you. And by golly, that's 2.732. Okay, well, what about the square root of 3 by itself? SQRT. 1.732. So, luckily it was A, so we got our answer. And this time we know for sure it is a solution. But if it didn't work, we'd go through and then we would end up getting our answer that way. So a little extra step, but I think a lot faster than some of the other methods available for this one. Next up, I've got the rule of 180. And the rule of 180 is more than just one rule in a way, because we can think of the rule of 180 as 180 degrees in a triangle, which is what it is in this case, but also 180 degrees in a straight line, which it also ends up being. Along with that, we've got a little bonus, which is isosceles triangles that will come into play for this one. So let's take a look here. We know that our goal is just to find out what x is, right? What is the value of x? And with geometry, I highly recommend labeling everything first. So let's do that. We know that ABC is 45. So I'm going to stick a little 45 up here. And in case you're not sure how to read these, basically the letter in the middle is the angle that we're looking for. And then ACD is 104. So ACD, this is 104. And then importantly, I almost skipped this. The very first thing it says is AC equals CD. So we can mark that AC equals CD. And this is super important because this goes to the whole isosceles triangle thing that I was talking about. If you have two equal sides, it means the corresponding angles are also equal, and you have an isosceles triangle. So basically D and A, these two angles are also going to be congruent. And now we can pull in the rule of 180, right? Because we know that the top of this big triangle is 104 degrees, and we know that there's only 180 degrees in a triangle. So if we take 180 and we subtract 104, we get 76. And we know that that has to be split up between these two angles, right? So we can label a little bit more. Split up that 76, that is to say divide it by 2, and we get 38. So now we also know that both of these angles down here are 38. And now we've already begun to engage in what I like to call ring around the rosy. We're going around, we're seeing what can we figure out? What can we figure out that's going to get us closer to that x? And we are actually really close to solving this now. Just a couple more things. We're going to use the rule of 180 again. This time it's going to be the straight line rule. We know that this is a straight line, so it's 180 degrees. We know that this side of the straight line is 104 degrees. So again, we're going to do 180 minus 104, but we already did that. We know it's 76. So we can label this angle 76. And now we can use the triangle rule of 180 to get the last angle in this triangle. Let me switch colors here. So we got 180, and this time we're going to subtract 45, and we're going to subtract 76. And I'm just writing this out so you can see what I'm doing, but just use your calculator. That's 59. And then there's another rule here, which is the vertical angles rule. Basically, whenever you have two tips touching like this, those angles are congruent. So if that's 59, we know that this is also 59. And then, as you can see, we just have to do that rule of 180 one more time. Now we're subtracting the 59 and the 38. And we get 83, which is x. And that's our answer. So I said the rule of 180 with a little bonus rule of isosceles triangles. We should probably add another bonus rule in there, which is vertical angles. So really it's just common geometry rules that you ought to know. And these are rules that are not on the reference sheet. So you really do need to have these memorized. Next up, we have
So many linear equations.
There are going to be so many linear equations on your exam. How do I know this? Because 32% of the questions in College Board's question bank are linear equations. So they're inevitable. And something that is really helpful to remember with linear equations when they are word problems is what each component of slope-intercept form represents. So just a quick refresher for you, we've got y equals mx plus b. And you should know that y is y, x is x, m is the slope, and b is the y-intercept, right? But in the context of a word problem, what do these things represent? Well, y is going to be your total, x is going to be the thing that affects your total. This is often time or a number of items being purchased. M is your constant rate of change. So if x were time, then m would be like, miles per hour. If x were an item that you were purchasing, m would be the cost of that item, right? So it's the rate of change in relation to x. And then b, your y-intercept, is your starting point. All right, with all that in mind, let's actually take a look at this problem here. And I do like to go to the main question first and decide how much of the rest of the question I want to read based on that. And the main question says, what is the best interpretation of the slope? So this is perfect. We can look at our little cheat sheet here because it's all about representation, interpretation, right? So the slope, according to what we just talked about, is a constant rate of change. So I'm going to eliminate any answer that is not a constant rate of change. Each game costs 25. That would be a constant rate of change, right? We talked about it being, the cost of things that are being purchased. The video game system costs 100. And I can already tell what's going on here because we know we're going to have multiple games for one system. So the system would be kind of like the starting point, the y-intercept, because you need to buy the system before you can start playing games. But we could also look at the other sentence here, and it tells us that more or less. But either way, B is not a constant rate of change because we're only going to buy one video game system. Again, C, only one video game system. And then D is also a constant rate of change. Each game costs 100. So now I just need to figure out, is the slope actually 25 or is it 100? We could grab a couple points and use the slope formula, but I'd rather just eyeball it because there are some pretty clear points here, right? We just need to do rise over run. So here we have 100, and then we want to draw a little staircase. So rise over run. We go up 25 because once we get here to 1, it's 125. Same thing here, rise over run. We can see that we're going up by another 25. So my answer is A. Next, we've got margin of error questions. I feel like these are sort of a sleeper that not a lot of people talk about, and they're not super common. If you're going to run into one, you're probably just going to run into one on the exam. But if you know how to handle them quickly, those are extra points that are very easy to attain. Basically, with margin of error, we need to remember that a margin of error says it is likely that the real percentage is either, this amount higher or this amount lower within that range. So for example, if I said, I did a study and according to my study, 64% of cats are evil, but there's a margin of error of 4%. That would mean it is likely, and it's important that we remember likely here because we don't know, but we can say with confidence that it's likely between 60%, so that's 64 minus the 4%, and 68%, so adding that percentage to the 64% of cats are evil. So that's all we need to remember for margin of error. The word likely, and we're going between a range of subtracting and adding the margin of error. And like I said, I do like to start with the main question, which is why I immediately saw that this was a margin of error question. It says, which is the correct statement on the given margin of error? And the reason that this is so fantastic is we don't have to look at this chart. We don't have to look at the whole question. We just have to figure out what the margin of error is and then sort of cherry pick from there. So here it says the estimate of heavy texters is 30%. So that's like my 64% of evil cats. And then the margin of error is 3. So in my head, I'm thinking it's likely that 27 to 33% of teens are heavy texters. And notice I'm not even looking at this chart because of this. So hopefully I don't have to. All right, and I'll write that down so we don't forget. Get rid of the cats. Cool. All right, now we eliminate answers that will not match that, basically. Approximately 3% of teens who are classified as heavy texters are not really heavy texters. No, it is not possible. Immediately, I'm seeing not possible. That's an extreme absolute statement, so B is probably not going to work. That sort of language is something you definitely want to look out for. Not possible that the percent of teens who are heavy texters is less than 27. So it's not likely, but it is possible. So that's why we get rid of B, and that's why I emphasized the likely. It's really important there. C, the percent of all U.S. teens who are heavy texters is 33. That's another extreme absolute statement. It's saying it is. It's not using likely. So C is out. It's possible, but it's not just the truth. And then D, it is doubtful. So doubtful is sort of the opposite of likely. It is doubtful that the percent of teens who are heavy texters is 35. Yeah, because it's likely it's 33 at the highest. So it would be doubtful that it's 35. So D is our answer. Next up here, we have what I like to call scary constants. And they are scary, but we shouldn't be that scared of them. This problem in particular is rated at a difficulty level of 3. So basically, the highest difficulty level according to College Board. But there are 2 easy ways that we can solve this. For sure, we could do a whole lot of substitution and solve it on paper, but for systems of equations, your first instinct should be to try out Desmos if you don't see another quick solution. Now, I don't think Desmos is the fastest way to solve this one, but let me show you how that would work real quick. Basically, we put both equations into Desmos, which I've done here, and because there's a constant involved, we're going to have to add a slider. So you click this little button that says Add Slider, and then what the slider is going to do is allow us to change the value of t. And the question is asking, what is the value of t? So The only hint we're given is that the system has no solution. No solution means the lines never touch. So I would need to move this slider around so that the lines are not touching and that they will never touch. Basically, they need to be parallel. And you can see when I get to 8, they are indeed parallel. Visually, it's kind of hard, but if you zoom in, you can tell. And if you wanted to double check, you could plug 8 back into the equations to make sure it works. So Desmos would work like that. However, I think there's actually a really fast way of solving this. So like I said, a system of equations with no solution means they never touch. As I just showed you visually, it means they are parallel. And if they're parallel, it means they have the same slope, which means they should have the same coefficients in front of x and y. Another cool thing is, regardless of if it has no solution or infinite solutions, we can focus on those coefficients in front of x and y, because no solution means that the constants, that is to say the leftover numbers that are not attached to x and y, they're never going to equal each other. With infinite solutions, they will equal each other, but we could still just focus on the coefficients because they're also going to equal each other. Anyway, let me stop saying equal each other and actually show you what this looks like. So I am just going to worry about getting the number in front of x to be the same because I know they have the same slope. So that's literally all I'm going to do. So the first thing I want to do is get these looking more like each other. The bottom equation, we have y on the left side, but then x is on the right side. So I'm going to just do a little flippity-doo-dah-day here and make that the case for the top equation as well. I'll start by moving the 10y over to the left. So we get negative 16y because I subtract 10 from both sides. And then I want my x to go over here. So I'm going to subtract 4x, which means that would equal negative 4x. And remember, I don't care about the constant, so I'm not going to even worry about it. I'm just going to leave it out of the equation. And I'm not particularly fond of negative numbers, so I'm just going to multiply this whole equation by -1 to turn these positive. Now, let's write the bottom equation, again, omitting the constant, because we don't care about the constant. Doesn't matter. Ty equals 2x. All right. Now, remember what I said. They have to have the same coefficients. So right now, if we have 4x up here and 2x down here, how do we get the bottom to be 4x? We just multiply the whole equation by 2. So then we get 2ty equals 4x. All right. And remember what I said, they have to be the same coefficients. So the 4's are matched up. That means that the y coefficient should also be matched up. So if we get rid of that y now, basically these should equal each other. Moving over here real quick, 16 equals 2t, which means t equals 8, right? We divide by 2. So our answer is 8. And I was writing all that out for you, but honestly, most of that, if not all that, should be able to take place in your head once you get used to it. For me, as soon as I wrote down these guys here, I'm immediately saying that we multiply 2 by 2 to get to 4x. So then what do we multiply by 2 to get to 16? 8. And at that point, I already know the answer is 8. So that's why it would go really quickly for me if I use this method instead. Definitely look for shortcuts when you come across these scary looking constants. For sure you can use Desmos, but as you can see, a lot of the time there's even better shortcuts. All right, and here we have percentages, and you are certainly going to be encountering percentages on the SAT. If you want me to make a more detailed video on the different types of percentage questions, let me know in the comments, but for now, let's just address this. We know from the main question that we are looking for the discount. And I like to start with the main question so I don't get distracted and lose sight of my goal. It says the total cost of this purchase was $75. That was the total cost. Emma's going to get a discount code to save 15%. That's subtract 15 off the total cost. So basically, we're taking that 75, we're subtracting 15%. And some of you smarty pantses out there might be like, ooh, I know. If we multiply 75 by 0.85, we're going to get the amount that Emma paid. And you're right, that's totally going to work. But remember, we're not looking for what she paid. We're looking for the discount. So we actually just want to multiply by that 15%, which is, 0.15. Throw that into Desmos if you want, and we get 11.25 as our answer, which is, pause the video and try each of these on your own first. I go really quickly through these math questions. Looks like we've got a linear problem here. It's talking about a line. So what does it tell us about this line? Intersects the y-axis at 0.0, -6, so it's giving us the y-intercept, and it passes through the point 22. It's also saying the point 20w lies on the line. So what can we do here? I would go ahead and figure out what the equation is for this line. That should make things easy, right? So we know that it's y equals mx plus b, and then b is our y-intercept. They tell us our y-intercept is -6, so mx minus 6. And then we can plug in 0.22 to figure out what our slope is. So 2 equals m times 2 minus 6. That means that if we add 6 to both sides, we get that 8 equals 2m. So basically our slope is going to be 4 after we divide by 2. So m equals 4. So now we can revise our equation here. Instead of y equals mx minus 6, we can say y equals 4x minus 6. And then from here, we just have to plug in 20 for x, because we have 20w, right? So y equals 4 times 20 minus 6. 4 times 20 is 80. 80 minus 6 is 76, or 74, I should say. So my answer is 74. All right, we've got a function here. Looking at it, looks like it's a linear function because we basically have y equals mx plus b. It's just the mx situation is a little bit weird, but it seems to be a linear function. Okay, what's it asking me? If a temperature increased by 9.10 kelvins, how much did the temperature increase in Fahrenheit? Well, let's think about this. So we could just plug in 9.10 for x here, but like I said, it's kind of weird looking, and I'm not super into that because it's asking about temperature increase, which should just be based on our slope, not our y-intercept. So first, I want to FOIL this out so that we don't have this weird looking linear equation, so that it actually looks like a normal linear equation and we actually know what our slope is. So basically, if we FOIL this out, we get f of x equals 9 over 5x minus 9 over 5 times 273.15 plus 32. And let me just separate here. Over here, we have our y-intercept, which I don't care about because a y-intercept in the context of a word problem is always going to be our starting point. So as far as the actual increase goes, the actual slope, we just have 9 over 5x. So to get our answer, all we have to do is 9 over 5 times 9.10. And just to be safe, I'll throw this into Desmos real quick. But basically we get 9 over 5 times 9.1, and that's 16.38, which is choice A. Looking at the answer choices here, we've got linear equations because all of these are going to be linear, as you should be able to tell. And really it's just asking us which equation is going to match up with the scenario. So we're trying to figure out, it looks like, what our y-intercept is going to be and also what our slope is going to be, since those are the two things that we see at play here. Let's start with slope because that should be pretty easy. We basically want rise over run. And here it says gasoline is $4 per gallon. $4 per gallon. And if we're talking about how many miles he should drive, instead of thinking about gallons, we need to think about miles. So the second sentence here says 25 miles per gallon of gasoline. So our slope should be 4 over 25. And we can get rid of A and B because of that. And if we're trying to reduce his weekly expenditure by $5 by driving a certain number of miles, if this is going to help us to determine the number of miles, because it does say M is miles, right? That should be equal to only 5, 5 being $5, because we're trying to figure out how many of those miles equals that $5. So that is actually choice D. Okay, so we've got a geometry question here, and this is asking about the volume of some sort of container. I do like to start with the main question so I kind of know what I'm focusing on, but let's take a look and see what this container is. It's a right cylindrical container. Okay, so basically it's like a soda can with a height that is 4 inches longer than the radius. So let's think about this. Volume of any regular cylindrical container is going to be basically the area of a circle times height. So it'd be pi r squared times height. And it says the height is 4 inches longer than the radius. So basically we just want to express that. So we could write it, and I'm not going to look at the answers yet. I'm going to change it so that it makes sense for me. If the height is 4 inches longer than the radius, it could be like volume equals pi r squared times, instead of height, we would have r plus 4, right? Because we're going to take our radius, we're going to add 4 to it to get our height. So I'm looking for that answer more or less. And none of my answers actually look like this. So let's unpack it and actually distribute what's in parentheses. So we would get r squared times r is pi r to the third. And then if we multiply by 4, it'd be plus 4 pi r squared. So again, I'm taking this and I'm distributing it to what's in parentheses here. And then that actually lines up with answer D. So my answer is D. All right. It's looking from the wording like we have a system of equations here. And the reason I'm saying system of equations is we have two different types of something. Whenever you see two different types of something, that's usually a pretty big indicator that you're dealing with systems of equations. More specifically, if you have two types of something with different values, so in this case, tickets with values of either 12 or 8, and then you have another total, which is like the total number of items, right? So we have total number of tickets plus the total price. That indicator that we're dealing with systems of equations. Anyway, let's set this up. So I'm going to say x plus y, that is kid tickets and adult tickets, equals total tickets, which is 30. And then for price, I'm going to have 12x price plus 8y equals 300, because it says we have $300 in total. And then how much in dollars was spent on adult tickets? So from here, you could definitely use substitution or elimination. I would prefer to just throw it into Desmos at this point. So I'm going to open up Desmos real quick and plug in my two equations, x plus y equals 30 and 12x plus 8y equals 300. Looks like I'm going to need to zoom out, so I'll zoom out, and then my intersect is going to give me my x and y values, x being adult and y being kid. Looks like they're the same. So regardless, my answer is going to be 15. We just have to be careful, though, because it's not asking us how many adult tickets were sold. It's asking us how much in dollars was spent on adult tickets. So if we know that there were 15 adult tickets, but each adult ticket is $12, then it would actually be 15 times 12, which would be 150 plus 30. So it would be 180 as my answer. All right, we've got systems of equations here, and from the answer choices, it looks like some pretty complicated systems of equations, right? Usually when you see radical signs, it's an indication that you're going to have to end up using the quadratic equation, but I would rather just solve this using Desmos. So I'm going to pull up Desmos. I'm going to put both equations into Desmos as my first step here. So x minus y equals 1. And then we had x plus y equals x squared minus 3. So let's take a look at our solutions here. We've got 2.732, 1.732, or negative 0.732, negative 1.732. But more importantly, we need to match these up with actual answers. So let me squeeze this down a bit to give us some room here so we can see. Our first answer, we have 1 plus the square root of 3 and the square root of 3. So if I just know what the square root of 3 is in decimal form, that should help. SQRT is a little shortcut, by the way. Square root of 3 is 1.732. That's familiar, right? That was our intercept over here, 1.732. So that would match up. Now we just have to make sure that the x value matches up. Well, if we add 1 to it, 1 plus the square root of 3, that would indeed be 2.732. So we got lucky. Our answer is going to be choice A. But if that didn't work, we would just go down the line testing our answers till we find one that works. Next question is looking like we have a quadratic. This is factored form of a quadratic, right? And it's saying, which of the following intervals contains the x-coordinate of the vertex of the graph f? Now, from factored form, if it's asking about the x-coordinate of the vertex, there's actually a couple of cool tricks. If it were in standard form, that would be negative b over 2a. But since we're in factored form, it's actually just the average of the intercepts. So if we have x plus 3 and x plus 1, that means x equals negative 3 and x equals negative 1. Average of those two would be negative 3 minus 1 over 2, which is negative 2. So the x-coordinate of our vertex is negative 2. That means that the x-coordinate is going to be greater than negative 3, so not A. It's going to be greater than negative 3 and less than 1. That's true. And then the other ones, they're not negative, so our answer is B. This question is something I like to refer to as just like interpreting a quadratic equation, because it gives us a quadratic equation, right? And then it's asking us what A represents. Well, what the heck is A? It says the graph intersects the x-axis at 0 and A. So basically we know that A is going to be the bigger x-intercept, And there's somebody doing something in the yard outside. Sorry if you guys can hear that. I'll try to cut it out with my magic editing skills. But anyway, well, let's think about what an x-intercept is. So visually, we do have an upside down parabola because it's A is negative here. So if we have something like this, then our x-intercepts are both going to be when the price is $0, right? $0, $0. So at some point, it seems like if we sell too many products, instead of making a profit, we're actually going to make $0. So I'm looking for something about selling too many products, making $0. That's what A would represent. So choice A, the revenue when the unit price of the product is 0. So it shouldn't be that the price is 0, because remember, X is the price, and we can see that X is not 0, Y is 0, so A is not going to work. B, the unit price of the product that will result in maximum revenue. No, I would say $0 in revenue is not maximum revenue. That would actually be up here. That would be our vertex. C, the unit price in dollars of the product that will result in a revenue of 0. Yes, this will result in a revenue of 0, and just like this will result in a revenue of 0. And sorry, to be clear, I think a second ago I said that X is how many we're selling. It's not how many we're selling, it's the unit price. So basically, if we price it too low, we're not making any money. And if we price it too high, we're not making any money. But yeah, C would work. So C is going to be our answer here. We've got a measures of central tendency question here. I know because I see different measures of central tendency in the answer choices. And it's asking, which of the following measures does not have the same value in both original and new data sets? All right. So let's take a look at what's happening and see if we can figure this out. It says we've got a data set of 27 numbers that has a mean of 33 and a median of 33. So this is telling me basically that these numbers are split up evenly. If you have the same median as you have mean, it means there's the same distance on average between the values. A new data set is created by adding 7 to each number from in the original data set that is greater than the median, and subtracting 7 from each number in the original data set that is less than the median. Let's demonstrate this by using a really small data set. Let's pretend that we have, we'll say 8, 9, 10. So the mean of this is going to be 9, and the median of this is going to be 9 because they're spaced evenly. We have 1 between each number. That's the rule that I was just mentioning. Now it's saying we're going to subtract 7 from each number less than the median and add 7 to each number over the median. So if we did that, our new data set would be 1, 9, and 17, right? Because they're still evenly spaced, because there's now 8 between them, the mean and the median are still going to be 9. So we know that those things would not be affected. So mean and median stays the same. The sum of the numbers is also going to stay the same because we subtract 8 and we add 8. That cancels out. So by process of elimination, it's going to have to be the standard deviation. And indeed, in a nutshell, standard deviation is basically like, on average, how far away from the mean are all of the numbers. We've got a percentage question here. It says percent increase. So I'm going to be using my percent change formula. And it says the manager estimated the percent increase from 2012 to 2013 would double. So basically this percentage increase that we can see here would double the increase from 2013 to 2014, which would be an increase that we can't see. How many subscriptions did the manager expect would be sold in 2014? All right, so let's start by finding the percentage increase here. So we'll use our percent change formula, which is the difference between the original and the new. Looking here, we can see that the difference would be 280 divided by the original number. The original number would be the first number, 5,600. We could get rid of a 0, get rid of a 0. If you know that 28 is half of 56, we basically have 0.5. But then we have to add the extra 0 because we have an extra 0 here, so it'd be 0.05. So that would be a 5% increase. And it says that that was double the percent increase that from 2013 to 2014. So then if we estimate that, we would have 2013, 5880. And now to increase half of 5%, so we would multiply by 1 for our original 100% plus 0.025. And that is something I don't want to do in my head, so I'm going to throw that into Desmos. 5880 times 1.025, and that is 6,027, which is choice B, which is our answer. All right, so this one I think is very tricky because it used to be that you could just read the last sentence for probability questions and kind of go from there. So if we read the last question, it says, if a person who preferred a picnic, so we know we're looking at this picnic zone, is selected at random, what's the probability that person responded by email? Right? And hopefully if you look at the chart and you see that it's percentages, it'll kind of solidify that things are a little bit off. Like we don't have all the information we need just from the chart here, which is normally the case. So if we kind of skim through the passage, we see a really important detail that we need to know, which is for the survey, second to last sentence, for the survey, the number of email responses was twice the number of phone responses. So I like to just basically think, we'll say like phone had 100 responses, email had 200 responses. So basically the whole email side would get doubled. So our desired, instead of being 5, we're going to say is 10. And then our total would be the 10 plus the 20, which is 30. So then our probability is 10 out of 30 or 1 out of 3. Up next, we've got sort of a ratio question. It's asking us, to the nearest hundredth of a meter, what is the length of one edge of this sample? So we know we're looking for an edge. What are we looking at an edge of? The density of a certain type of wood is 353 kilograms per cubic meter. Okay, so we're looking at the edge of a cube, it seems. And let me just write that ratio down. It's 353 kilograms per cubic meter. We'll call that like m to the third. That's our ratio. A sample of this type of wood is the shape of a cube and has a mass of 345 kilograms. So we have a sample that is 345 kilograms. Let's first figure out how many, because this is 1 over here. Let's figure out how many cubic meters we have in the sample. So we'll cross multiply. 345 times 1 is 345. Then basically 353x. So we will divide both sides by 353. And I'll pull up Desmos to make my life easier here. So again, those numbers were basically 345 divided by 353. So we have 0.977, which is basically 0.98, but we have to be careful because 0.98 is one of our answers. But remember, it's not asking us how many cubic meters we have. It's asking us the length of one edge of this sample. So we would actually need to cube root our answer here. So it'd be like the cube root of 0.98 is going to be what we're looking for, because a cube is basically length times width times height. So one edge would be either the length, the width, or the height. So then if we throw that into Desmos, basically we could just take what we already have and cube root it. And that was just CBRT, by the way. 345 divided by 353. Probably get rid of that. And now we see it's actually 0.99, which is choice B. So be really careful about wording because they will always have wrong answers that line up with missing a step, right? So this question here is going to be about evaluating statistical claims. It is saying which of the following statements must be true. And basically, we just want to kind of read through the scenario and then eliminate anything that might not be true. So here it says, to determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. All right, so we have our full understanding here, right? Choice A, the mean number of children per household in the community is 2.4. That's not going to work because whenever we take a sample, it does not mean that we get the actual statistics on the population that we're sampling. We would never be able to say is. Furthermore, 20 families is a really small sample size, and it's also only families at a playground. So big issue there with saying in the community. It would have to be something more like who go to the playground in the community, and probably just a bigger sample size than 20 families. B, a determination about the mean number of children per household in the community should not be made because the sample size is too small. So in general, 20 is a very small sample size, like I just mentioned. That said, we don't know how many people are in the community. So that one, I don't think has to be true because it says must be true. It might be true. I think it's true. But because we don't know how many people are in the community, we can't really determine if it's too small. So we'll get rid of B. C, the sampling method is flawed and may produce a biased estimate of the mean number of children per household. Yeah, that's what I was saying when I said they're only surveying families at a playground. It's not random. So C is definitely going to work, and that's going to be my answer. But if we wanted to be safe, we get rid of D. D, the sampling method is not flawed. No, we know it is flawed, right? So our answer is choice C here. All right, we got a SOHCAHTOA question here. It's asking about sine of x. So in SOHCAHTOA is OH, that's opposite over hypotenuse. Opposite x is 16, divided by the hypotenuse, which is 23. So my answer is 16 over 23. All right, so we've got a circle graphing question here. And the way that it's written, I can tell that we basically want to stick this into the normal version of the equation, which would be like x minus h squared plus y minus k squared equals r squared. And this isn't a huge deal. We basically just have to break this down, complete the square, so on and so forth. But it's going to take a minute. So I would probably just throw this into Desmos because I think it's going to be a little bit faster. So if we pull up Desmos, we'll throw it in. It was 2x squared minus 6x plus 2y squared plus 2y equals 45. We're trying to find the radius. So basically, we find the difference between the top and the bottom. That's going to give us our diameter. So we have y is 4.5. Y is negative 5.5. So the difference between those would be 4.5 minus negative 5.5. So basically 10. Half of 10 is 5. My radius is 5. My answer is 5. See how that's a lot faster? Power of Desmos, baby. Sneaky math questions that tend to show up at the beginning of the second module, provided you've gotten to the harder math module. And I call them sneaky because it looks pretty simple, and it looks like we could actually just get away with eyeballing this. We know that we want to go to where x equals 5, and we can just kind of like draw a straight line up, and like right here, it's looking like it's pretty much just 5.5, right? So what is 5.5? That would be 11 over 2. That's my answer, yeah? But this is a mistake. You really do want to take the 2 points that they gave you and figure out what your slope is and then kind of go from there. So we have 9 and we have 13. The slope is going down, so we know our slope is negative 9 over 13. And in fact, we know our equation is going to be y equals negative 9 over 13x plus 9, because that's our y-intercept as well, right? So from here, we actually need to plug in 5 for x. And we get y equals negative 9 over 13 times 5 plus 9. And all of this ends up simplifying to 72 over 13, which is choice C. Next up, we've got simply perpendicular lines. And for perpendicular lines, we just need to remember that the slopes are the opposite and they are the reciprocal. So here, if we were to turn this into slope-intercept form, we know that that 13x is going to move over to the right side. We would subtract it. We would have 3y equals negative 13x plus 37. And then this whole thing is going to have to get divided by 3 to get y by itself, right? So then our slope ends up being negative 13 over 3. So what is the opposite inverse of that? Well, instead of negative, it would be positive. And instead of 13 over 3, it would be 3 over 13. So we're looking for 3 over 13, which is choice A. All right, last up, we've got product of the solutions to either a polynomial or usually a quadratic. In this case, we have a polynomial. But the cool thing is, if our polynomial is in factored form, like this is, it's going to be the same exact shortcut as if we're dealing with just a quadratic. So our formula for factored form for a quadratic would normally be y equals a times x minus p times x minus q. The product of the solutions is just p times q, because p and q are the solutions. The one thing you need to look out for is that because it's minus p and minus q, whatever those numbers are, they're going to have their sign flipped. We can do the same thing here. We just have to multiply negative 9 times 3 times negative 4. This is going to end up being positive 108, But remember, because it's minus p and minus q, we follow that same rule with any polynomial, so this will get flipped to negative 108. Our answer is choice C. And then if we are in standard form, there's another shortcut. Standard form would be y equals ax squared plus bx plus c. And here, our shortcut is going to be c divided by a. That's going to be the product of our solutions. Now, this up here looks absolutely crazy.
It's crazy.
But the good news is all of this stuff in parentheses is actually just b because it's being multiplied by x. It's the coefficient for x. So we can ignore it. We don't care about that. All we care about is c, which is going to be ab in this case, divided by a, which is 11 in this case. And then it's telling us the product of the solutions, which is AB over 11, is RAB. So this is equal to RAB. Those are my initials, by the way. Very cool. And then it says R is a constant. What is the value of R? Well, we just have to simplify and solve for R. We can get rid of AB because it's in the numerator of both of these. So then we're left with 1 over 11 because there was an invisible 1 in front of the AB, right? Anything times 1 is itself. So our answer is 1 over 11, which is choice B. We've got special right triangles. And luckily, you are going to get this image in your reference sheet on Blue Book. So you don't have to memorize this, but just remember to actually pull up the rules and look at this if you notice you're running into these questions. What I would memorize is these numbers. If you see 45, 45, 90, if you see 30, 60, 90, go ahead and pull up your reference sheet so that you know what to do. But these are going to be the rules. And let me just kind of show you what this looks like, right? Here we have a 90-degree angle. We also see that this is 45 degrees. Because a triangle can only have 180 degrees, this has to also be 45. So we know we've got a 45, 45, 90. Let's say we're solving for x. So we know from our little image here that we have a side, we have an even side, so we could say this is x as well, and we have the length of one of those sides times the square root of 2. In this case, they tell us that the hypotenuse is 7. So we could say 7 equals x times the square root of 2. And we're trying to solve for x, right? So now it's as simple as getting x by itself. Divide by the square root of 2, we get 7 over the square root of 2 equals x. One thing though, in your answer choices, you're probably not going to see this because math folks don't like square roots in the denominator. I'm not sure why, but they don't like it. So we have to convert this. We would have 7 over root 2. And what we can do is we can multiply by the square root of 2 divided by the square root of 2. The reason we're allowed to do this because anything divided by itself is just 1. And then it rewrites as 7 root 2 divided by square root of 2 times the square root of 2 would just be 2. And that's the answer that you would be seeing in the answer choices. So quick example of how to apply this right here. With that in mind, go ahead and pause the video and try this question. But here we go. So it's telling us that ABC is an equilateral triangle, and we can already kind of see that, right? We see that these guys are 20. We see that this is 20 because we have 10 and 10. Equilateral meaning all of the sides are the same and all of the angles are the same. In this case, they were also kind enough to include the 30 and the 60, but we should already know that we're dealing with a 30, 60, 90 anytime we cut an equilateral triangle in half. It is asking us what the value of AD is. Where is AD? It's actually this line down the middle. So 30, 60, 90, that means we have x here. We have 2x here, and we can see that's true, right? 10. 10 times 2 is 20, which means that this side right here is going to be 10 times the square root of 3, according to our little cheat sheet here, right? So just like that, our answer is choice A. Up next, we've got linear equations with no solutions or infinite solutions. And the thing that we need to remember about no solutions and infinite solutions, as long as we're dealing with, a linear systems or a linear equivalent expressions, is that they both are going to have the same slope. And I might as well just show you on Desmos real quick. So let's say we have y equals 3x plus 4. I'm just pulling that out of nowhere. No solutions would be the same slope, right? Y equals 3x, same slope, slope being 3. And then we'll give a different y-intercept. As you can see, these guys are parallel. They're never going to touch. They're never going to have any solutions because a solution is when they're touching, right? But if I said 3x plus 4, the same exact equation, now they are overlapping each other. They have infinite solutions. They are equal to each other. So yes, we have the same y-intercept this time, but we still have the same slope. So it's easy to remember that regardless, you can look for the same slope if it says infinite or if it says no solutions. So here we have a constant, right? It's saying mx plus 43 equals 7x plus 14. Now, if this expression has no solutions, we don't care about the 43 and the 14 because they're never going to be equal. But we know automatically that m must equal 7 in order for them to have the same slope. All right? So try this question on your own with that in mind. But here we go. For this, again, it says no solution, so I really do not care about this stuff. And even if it was infinite solutions, I probably still wouldn't care because I'm just looking at the slope, right? So all I care about is this, 5mx equals this, 45x over 19. I don't like having x and m here, so I'm going to divide the whole thing by x to get rid of it. And now 5m equals 45 over 19. So we just have to divide both sides by 5 in order to get m by itself. Now we could multiply by the reciprocal. We could multiply by 1 over 5, or we can just plug this into Desmos and make it easy on ourselves. So I'm going to plug this into Desmos real quick. Again, we're doing 45 over 19, and I can highlight that whole thing divided by 5. Alternatively, I could do 45 over 19 times the reciprocal, 1 over 5. You're going to get the same answer, right? And this is terrible, and we could definitely write 0.47, but it probably feels better to just write the fraction. So if you click this little button right here, you get your fraction, and our answer is going to be 9 over 19. And again, that comes from just focusing on the slope. Our next problem type is exponential equations. These guys can get a little bit more complicated than this, but in essence, this is what you want to focus on. You're going to have your total on the left side of the equation. After that, you're going to have your starting value. After that, in parentheses, and this is oftentimes one of the most important things to focus on, is going to be an increase in percent or a decrease in percent. And then finally, your exponent is some amount of time. And this should help you handle most exponential equations on the SAT. There are some more complicated variations, but once you get used to this one, you should be able to learn those with relative ease. So keep this in mind, rewind and go back to it if you have to, but pause the video and try this question based on what you just learned. All right, so here, I'm going to skip to the main question because I don't like reading, and it says, which of the following best models the thing that we're talking about, right? So basically, I'm just choosing an equation that goes along with whatever they're saying. And I'm already noticing that the only difference in all these answer choices is my percent increase or percent decrease. So if I just find out what that is, I'm good to go. It says we're increasing each year by 10%. Importantly, if we increase by 10%, we're going to multiply by 1.10. The reason being is that we have our original 100% plus the additional 10%. So no, it would not be choice A. It would be choice C. All right, next up, we've got these tricky systems of equations word problems where you think you're answering one thing, but you're actually answering another. Let me show you what I'm talking about. So here we have a system of equations, and it's pretty easy to tell that you have a system of equations because we have two different types of things and we have different values associated with those two things. In case you're not familiar, this is the most common type of systems of equations that we're going to run into, is basically two linear equations in standard form. So we've got our items, x and y, and we have our associated values, a and b, and then c is going to be a total. And it could be a total value, or it could be a total number of items. So here, we could set this up as value plus value equals value. We know that we've got $10 for general tickets. We'll call general tickets X, plus $6 for student tickets. We'll call those Y, equals, and since we can see the value, the 10 and the 6, it's going to be value plus value equals value. And they give us the total value of 340. And then our other equation is going to be items, which are tickets. So all of the general tickets, X, plus all of the student tickets, Y, is going to equal the total number of tickets, 40. And that's our system of equations. At this point, I would recommend just plugging this into Desmos. So let's go ahead and do that real quick. And it looks like we're going to have to back off a bit to find our intersection, but there it is, 25, 15. So 25 is X, 15 is Y. Now let's go back to our question. What were they asking about, X or Y? Well, it said how many dollars were collected from the sale of general tickets? General tickets being X. So if X was 25, which it was, remember we looked at Desmos, X is 25, then we might be thinking our answer is 25. But this is where it gets tricky. You need to make sure that you are answering for the correct thing, either value or items. 25 is the correct answer for items. That's going to be the number of general tickets. But it's not asking about the number of general tickets. It's asking about the dollars collected from general tickets. So we have to take that 25 and multiply it by its assigned value, 10. So our answer is actually going to be 250. Our last question type is upsetting constants questions. For example, this might look like a little bit of a nightmare to some of you guys. We've got this polynomial with stuff moving up to the third degree. We've got a and b. They are asking us the value of a and b multiplied by each other. What the heck's going on here, right? Well, the good news is with these equivalent expressions questions, we really just have to focus on like terms. So looking at this, for example, we have wx squared plus tx squared plus f equals 3x squared plus 8x plus 11. And our like terms are going to be determined by if they're being multiplied by x squared, by x, or by nothing. So on the right side, the only thing being multiplied by x squared is 3. So 3 has to equal w because those like terms are always going to be equal to each other. Likewise, t is going to be 8, f is going to be 11. And in a nutshell, that's really all we need to focus on for these particular type of constant questions. So pause the video and try this on your own first, but here we go. So in this case, they're asking about the value of a, b. Now, you could say, well, I want to focus on a, and I'll find out what it is. And then I'll focus on b, and I'll find out what that is, and then I'll multiply, and then I got my answer. But there's a shortcut. Here, they're asking about AB. So let's actually focus on AB. As we FOIL the left side out, the only time that we're going to get AB is when we multiply AX times negative BX. And we're going to get negative ABX squared. So now I know I only have to focus on things being multiplied by x squared. Those are my like terms. So on the right side of the equation, this is going to be equal to negative 7x squared. And you might be thinking, all right, we're all done. We've got it. We're good. But you would run into an issue because these are not all of the x squareds. We're forgetting about 4x squared times 2 on the left side, which would be 8x squared. Now they're all accounted for. So what we can do from here is subtract 8x squared. Well, actually, let's get rid of the x squareds first because those are annoying. We could subtract the 8 Over here, we get negative 15. If negative AB equals negative 15, then positive AB equals positive 15, and our answer is choice C, 15. Perpendicular lines. And the thing you need to know about perpendicular lines is that they form a right angle, and because of this, their slopes are the opposite reciprocals of each other. So for example, if I had something like y equals, I don't know, just 3x, the opposite, yellow is a terrible choice. Y equals 3x. The opposite of 3 would be negative 3. So when I say opposite, I mean, negative turns positive, positive turns negative. And then the reciprocal is when you have a fraction, so 3 over 1, and you flip it. So it would be 1 over 3. So the opposite reciprocal would be negative 1 over 3. And there's a beautiful graph as well. So you can see that these guys indeed form, right angles with each other. Anyway, on to this question. So we know that line J is perpendicular to line K. So the first thing that I would do is probably just put it in slope-intercept form, because for me, that's visually easier to see. So I'd move that x over. We get y equals negative x plus 4. So we already know that the slope of line J is going to be just x, because, this is basically negative 1x, and 1 over 1, the reciprocal is still 1 over 1. But then it just flips to become positive, right? And then it tells us that the y-intercept is 0, negative 6. So actually, I know the full equation for this other line. It's going to be y equals x minus 6, because this is the y-intercept, and in slope-intercept form, this is the y-intercept, right? Now, I don't have that as an option, but I just have to move stuff around, right? Because this is all in standard form. So basically, if I moved my y over to the right side and I moved my 6 over to the left side, I would subtract y. So we would have x minus y. And then on the left side, I would have to add that 6 to move it to the left side. So then x minus y equals positive 6. That's going to be choice C here. And that's going to be our answer. And speaking of perpendicular lines, my next prediction is tangent to a circle questions. All you need to know about a line that is tangent to a circle is that it is perpendicular with that circle's radius. So when they tell me that line M is tangent to a circle at point 7, negative 1, and that the circle has a center at the origin, we can imagine we've got our circle here. It's right at the origin, right? So this is 0, 0. And then whatever this point is, 7, negative 1, I don't know, let's say it's over here. We can see the radius right here. And we know that the line is tangent to it, so it forms that 90-degree angle, right? So visually, this is going to be not great, but I'll do my best. It's really bad. Visually, it's something like this, right? We have a straight line. We're forming a 90-degree angle. So all we have to do is figure out what's the slope of our radius here that we drew, and then the opposite reciprocal will be the slope of line M. And since we have 2 points, we can just use the slope formula. Or if you're really lazy, you can just plug it into Desmos as a table. And I'll show you that because I think it's a nifty little trick, especially if you have bigger numbers or something. This one's obviously pretty straightforward because y1 minus y2, x1 minus x2, they're all 0, right? So we know that our slope is negative 1 over 7. But I could also grab Desmos and literally just put it in as a table. Type the word table, x1, 0, y1, 0, x1, 7, y1, negative 1. Click this little button here, boom. They tell us everything, right? We know that the slope is going to be this decimal here, which isn't quite as helpful, but if we typed it out and matched it with our answer choices, it's basically going to be negative 1 over 7, right? Like if I go to line 2, negative 1 over 7, that's the decimal that we're looking at. So, and remember, this is the slope of the radius that we drew. So the opposite reciprocal would be positive 7 over 1, also known as 7. My next prediction, forms of quadratics questions. And knowing forms of quadratics is going to be useful in getting the correct answers on certain questions, but it's also going to just make things go faster on other questions. So for this one, for example, you could easily plug this into Desmos and get your answer. We just grab our calculator, plug it in, and then look at our x-intercepts, and we know the other one is 6, 0, right? So our answer is 6. And that was fast. But if you are aware that we are in vertex form here, and you know because we're in vertex form that the vertex is 3, -18, and we know that the first x-intercept is at 0, 0, the x-coordinate of the vertex is going to be the midpoint of the two x-intercepts. So if we start from 0 and go to 3, we just have to add another 3, and then our answer is 6. So saves you like, I don't know, maybe 2 seconds. But a cool little trick if you ever run into another one of these where you have 0, 0 as one of the x-intercepts. Next up, we've got tricky unit conversion. And I did say that this is tricky, so go ahead and pause the video and try this one on your own first. And let's see how many of you choose the trick answer. So it says, a rectangular nature reserve has an area of this number square yards, which is the closest to the area in square miles of this reserve. So we know we're converting units because we have yards turning into miles, and they give us the conversion, which is nice. Now, the reason this is tricky is a lot of students are going to simply use this conversion, right? If we want to turn these yards into miles, according to the conversion here, we really just have to divide by 1,760, right? And if we do that, we get 4,066.18, choice D. But choice D is not the answer. And here's the reason. It's not talking about yards and miles. It's talking about square yards and square miles, which means this conversion isn't going to work straight up. Instead, we have to square our yards. So instead of 1760, it would be 1760 squared. And then we get the correct answer, which is 2.31. Boom. And my last prediction for the math section is going to be constants matching questions. And these kinds of questions are kind of scary looking, but there's a really cool trick that we can use to solve them, which is the matching trick. So if we have equivalent expressions like this, and we're dealing with multiple constants, we just need to isolate like terms. And what's even better is we don't even need to isolate all of the like terms, just the ones that we're looking for. So here it says we're looking for the value of AB. So I am going to start to FOIL out the left side, but I'm not going to FOIL out the whole thing. I only care about where AB shows up. And the only time AB shows up is when AX gets multiplied by negative BX, which would turn into negative ABX squared. So we have negative ABX squared. And the cool thing about equations is all of the like terms are going to be equal to each other. So this combined with all the x squareds is going to be equal to all the x squareds on the right side. And on the right side, we have negative 13x squared. I don't care about this. I don't care about this stuff because we're just focusing on whatever AB is attached to, and it happens to be attached to x squared. Now, this is not quite finished because we still have to account for any remaining x squareds on the left side. And when we multiply 3 by 5x squared, we would get 15x squared. So we would add 15x squared as well. And then from here, it's pretty straightforward. We can get rid of x squared because we divide the whole equation by x squared. We subtract 15 to get it over on the right side. And then we have negative AB equals negative 28. So positive AB would equal positive 28. So our answer is choice C.